Hi everyone. Today we are going to do revision for week 1 to 4 for your quiz, and we'll be doing questions on from week 1 to 4 for you to do the question, for you to be able to do the questions in your quiz. So I'll just share my screen. Give me a minute.
Ma'am, actually, any link for these meetings which are held on 8 to 10 p.m. for maths are not available on our dashboards, and we are not
It,
able to access
it's on
these
your
recordings.
calendar, right? It's on your calendar.
There also we can't access the recorded live sessions.
Yeah, the live session is on YouTube.
No, ma'am, but we are not provided any link to these meetings on any dashboard or these Google calendars. Nowhere it is given to us.
Should be on your calendar. The link for the session should be on your calendar.
I'm asking for the recorded live sessions, which I
The
can.
live session is on YouTube.
Ma'am, it is on YouTube, but we are not provided the link of that
I'll
live
just
session.
write the name of I'll just write the name of the YouTube channel then.
Ma'am, how long does the video remains on YouTube, the live session? For how
It's
many months?
there. I guess it'll be there for the whole semester, this whole semester. And it's the
But,
previous
but
semester.
ma'am, other subjects we have that on YouTube, but for maths we don't have any these meetings which are held like regularly.
How do I get the link?
I'll just share the name of the YouTube channel only. Wait. Yeah,
But where there is not the maths live session, particularly
there
these live
is.
session which you are taking and other are taking on 8 to
Is
10 p.m.
available on
There is not
YouTube.
for the math subject. Other subject like
There
stats
are live
and
sessions. You need to
these
check
are
that in,
available.
live stream section. There are live session available. I actually watched them. You can recheck actually. Let me share you the link.
To the YouTube channel on the, yeah, just put it in the chat box. Thanks.
Ma'am, now will
Ma'am,
you share like
will it be recorded? Will it be provided on the YouTube also?
Yeah, all of these
Will
sessions
it
are
stay?
recorded and they are on the YouTube channel.
Okay, ma'am. Thank you.
Okay.
ma'am, will you first summarize the theory and then you'll go to the questions or directly you'll jump into the
No,
questions?
we're doing the questions directly because let's just do some problems.
Yeah, okay.
If there's anything in particular that you want to discuss from theory, we can do that here. If there's a doubt somewhere. Else it's better to do the questions. Okay, let's just start with this question. This is a very easy question. Uh, so you've been given that the Cartesian product has 9 elements. So if this has 9 elements, that means A has, okay, Cartesian product means this form, right? Where A is coming from this capital A and then B is coming from this capital A again. So these type of elements are in the Cartesian product, and this the order is given to be 9. And then that means the order of A should be 3, right? And you have already been given 2 elements from A. So 1 is given to be 1. So that means if 1, 3 is in A cross A, that means both 1 and 3 are in A. That means 1 and 3 are two elements of A. And then if 3 and 7, this tuple, if is in this Cartesian product, that means your 3 and 7 both are in A.
Ma'am, what is the meaning of order in a Cartesian product?
Order just means order of a set means the number of elements. The cardinality of the set is what we call order. That's the same thing. The cardinality is the more used term. So this should be the set. So A is this set and the number of elements here are 3. So if you take the sum of all of them, it will be 11, right? So
Right.
sum will be 11. That's what you've been asked in this question.
And can you repeat this?
Okay. Cartesian product A, when you write A cross A, this means the collection of these type of elements, A, B, where A and B both are coming from A, right? This is what it means. So if you have been given that the total number of elements here are 9, that means the total number of elements in A should be 3, right? If you have been given that the total number of elements in A cross A is 4, let's say, so how many elements? That means the total number of tuples, these things are 4. And because both the sets are same, what happens is the cardinality of A cross A or A cross B for that matter is cardinality of A times, so if you're taking the cardinality of A cross B, it will be cardinality of A cross cardinality of B. This is product. So the cardinality, this cardinality should be this, right? Or you can just take 9. So this would mean that your A square is 9. And since your cardinality is always positive, that means your cardinality of A is 3.
Okay.
The number of elements in A is 3. And you've already been given 1, 3, and 3, 7 to be in A cross A. That means 1, 3, and 7, all of these elements are in A. So these are the elements in A because there are only 3 elements in A. And then you just take the sum of these 3. That's it.
Ma'am, if it is A cross A cross A, if it is 3, like A cross A cross A, suppose
Okay.
then.
If it's A cross A cross A, then your A, the order of A will be cube root of 9. The cube root of 9 is not actually a natural number, right? So that won't be given to you. Something you can be given 27 then. So here you will be given 27 elements or something that's a perfect cube. And so that you can get a natural number here.
No, ma'am, what I was saying is like the cardinality of A cross A would be in the form of A comma B comma C, na? Like
Yeah,
this, na?
yeah, the elements would be of this form.
A comma B comma C kind of.
Okay.
Ma'am, can you just be a little right? I wanted to take the screenshot of the right, what you have written on the right side, yeah. So you said the cardinality here is 3.
Yeah. Can we move on to the next question?
Yes, ma'am, please.
Okay. So the next one is this one. So this is the question. You have been given a relation where the two real numbers would be related to each other if their square sum is 1. For example, 1 and 1 are related to each other. This is one instance of, so 1 and 1 is going to be, this tuple is going to be here because the square sum is 1 of these two elements. This is just one example. And they're asking if R1 is a reflexive relation. So for a relation to be reflexive, if you have defined that relation on A, right? So the relation would be a subset of this, right? But you have defined it on real numbers. So it should be a subset of R cross R then. So this relation R1 is a subset of R cross R. And what you want here is you would want every real number to be related to itself, right? For this to be a reflexive relation, you would want every real number to be related to itself. That means
Okay,
this
ma'am.
thing should be in R1. That's how you define reflexivity, right? So And is it true, by the way? If you will take,
Yes,
is
ma'am,
it
it
true
is
for all
true.
real numbers? Is it true for all real numbers? If you will take, let's say I'll take 2. 2 is a real number. And if I'll take 2 square plus 2 square, it's 8, which is not 1.
Oh, so for all real number, it is not true, but
Yeah.
like I was answering the first option, it is reflexive relation.
No, that's not a reflexive relation because it's not true
And
for
can you
every.
explain in short what is reflective relation, symmetric relation?
Yeah, sure. Okay, for a reflexive relation, what you do is first you need the set. So if you've been given a set, then for reflexivity, and then the relation would be of this form, AB, where A, B are coming relation, you can define anything. These two elements are coming from A. So for this to be a reflexive relation, what you want is you want A to be in this set. Let's just call this set to be S, where S is a relation, or let's just call it to be R only. Let's just call this thing R. If this is a relation on A, that means your AB is coming from A. For this relation to be reflexive, you would want every AA to be in this relation. For all A, this is the symbol for all. Let me just write for all only. For all A belonging to A. That's when you say that this relation is reflexive, right? So for example, in this case, the relation is defined because how do you know it's defined on real numbers? Because it's given here. Yeah. You've been given real numbers, right?
Yes, ma'am.
Yes, ma'am.
So you have to check it for every real number. So you can take any random, like for instance, we took 2 comma 2. Now this 2 comma 2 is because you have to check for all A in the in this set capital A, and here your capital A is R real numbers, right? So you have to check for every real number, but it's not true. This is not true for 2, and it's not true for a lot of other real numbers too. But let's just take it's also not true for 0, 0. That's the simplest example. It's not true for 0, 0. So if you'll test this here, you'll get 0 square plus 0 square, which is equals to 0, not equals to 1.
Ma'am, I have a doubt. Can we take can be the value of x and the value of y can be same? For example, if we take 1 comma 1, so can we take that value for the x and y both?
Then it will not be in the relation because
That will be
1
answer
plus
It's a
1
2.
is 2.
relation.
Then you can take
And
1 by root 2, 1 by root
yeah,
3.
it's not, you're right. This is, in fact, I've written this thing wrong here. Sorry. Sorry
You
for the
can take,
confusion.
ma'am, 1 by
Ma'am,
root
square
2.
is never
Ma'am,
negative
1 and
now.
minus 1. Ma'am, 1 and minus 1.
Can't take 1 minus 1. You will put 1 here, minus 1 here, the sum will be 2.
Positive,
The
ma'am.
Still,
sum will be 2.
still it's 2.
This will because
by
square
root
is
2.
positive.
Yeah.
Only,
Yeah.
I think 0, comma 1 and 1, comma 0 can be
1 comma 0, 0 comma 1. And then if you want to go find more things, you can take 1 by root 2. And then
1
1
by
by
root
root
2.
2. I think
Same.
this works too. This will also work. There are a lot
Ma'am,
of numbers.
Ma'am,
Sorry, we'll
reflexive means suppose we are defining a relation on A and A has A, B, C elements, 3 elements, let's say, then A, B, B, C, C should be there. Is that?
Yeah, that's what it means. So let's say you've always given a set where you're defining the relation. What happens is your relation is always a subset of, that's how you define a relation. Relation is this thing, subset of A cross A. So you need this set. That's how, because to check if this relation is reflexive or not, the condition is this. Reflexivity of A cross A should be in this relation for all A. This is the symbol for all A belonging to A. So you
Okay.
need to know this set. If your set is 1, comma 2, comma 3, then you would need 1, 1, 2, 2, and 3, 3. All of these things to be in the relation, or the relation to be
Uh,
reflexive.
ma'am, I understand this example, but the thing is that like R is the subset of A cross A, but I couldn't get it, ma'am. Or
This thing,
like A cross, yeah, ma'am. A cross A is is the relation. But A comma A, what does it define? A comma A, like small a,
This
you write A cross A na, but after that you wrote A comma A, small a
this
comma
thing.
small a. Yeah, ma'am.
I
Why?
don't un-
How you Could you explain this process?
This is the definition of reflexive relation. So relations, when you look at, they're in this form, right? A, B, where you put a condition on A and B, right? If you're defining a relation on A, let's call it R. Then how do you define it? You take this tuple, or you can say this pair, where A, B have to be in A, and then there has to be some other condition that you can put, right? If you
Okay,
want
okay.
to, some other condition like A plus B should be 1 or something else. So that's the condition that you do. So first condition on these two is that they should be from A, from this set. If you're defining this relation on this set, that means these two elements should be from A. That's why, and for reflexivity, so this is how you define a relation. For reflexivity, you would need A comma A connection to be here in this relation. So if you want to
Ma'am,
call
why
this
you
a
wrote
reflexive
A comma
relation,
B? Here A comma A and B comma B, we can wrote na. We can write, ma'am, for right side, sorry, left side, ma'am, A comma B, where you wrote, like A comma
this
B,
thing,
where A comma A ना आएगा वहाँ पे.
no, this is a relation. For example, let me just give you an example. Let's just say you're defining a relation where you say, let's take the set to be this. Let's take A to be this, and then you're saying that we're taking A comma B, or you can take, these are arbitrary things. Doesn't matter, you take A comma B or A comma B because, okay, let me just define it first. Where A, B is from A and the sum of A and B is equals to 2. Let me just say I've defined the relation to be this. Then you will have to take two different things. No, otherwise this would mean that you can only have this type of things here. If you write this relation down, if you write this relation down in number forms, you will get 1 comma 1 only. No other thing. Or let me just have 0 here as well. 0, 0, 1, 2, 3. Then you will have 0 comma 2 as well, right? And 2 comma 0, 2.
2 comma 0
This
as well
will be
as.
the set. That's
No.
it, no?
Did you also add 0, 0, 1, 2, 3 in A?
0, 1, 2, 3.
Okay, ma'am.
So
And ma'am,
if this is,
along with this A comma A, there can be more, means
yeah,
more tuples, right?
yes. That's why we don't write AA here. We're not sure if all the elements in this relation look like AA. This one does and the others don't.
Okay.
So, ma'am, coming back to the question, we can say that is it a
Yeah, coming
reflexive
back to the
relation?
question, this is not a reflexive relation.
Because every
Not
element
reflexive.
should follow that criteria of AA, na?
Yeah, every element. That's why I've written for all A. This is very important.
Ma'am, like for
All
example,
A.
if 1, 0 ordered pair satisfies the condition, but we don't have, but 1, 1 and 0, 0 doesn't, so it is not a reflexive relation, right?
Yeah. Even
Okay,
if you're
thank you.
able to find one tuple where this does not satisfy this relation, that means you just need one tuple which does not satisfy this thing for this to be not reflexive.
So from the entire domain, we are just writing the ordered pairs which satisfy the particular condition into a relation, and from that we are checking, from that relation we are checking reflexive, symmetric, and transitive and all, right?
Yeah. Yes.
Ma'am, 1 by root 2 plus 1 by root 2 will satisfy the relation. Then it can be reflexive. But why we are not considering it? 1 by
Okay.
root 2 plus 1
Because
by
this
root.
is the only element that is satisfying.
Just
What
give
about
me a
1 comma
second.
0?
This
Oh,
will be
okay.
applicable
Can you
for
test
all
for
values of A.
reflexivity?
What are
And
the
this
correct answer?
goes for 1 second. Let me just write down these. There are some nuances that are not clear, I guess, to everybody. Let me just clear those things first. In reflexivity, or in other things as well, symmetry and transitivity too, it's the same case there too. The condition is if you're defining R relation on set A, this is relation. This is the set on which you're defining the relation. That what you want is, you want AA to be in this, right? And this should be true for all A. This is very important for all A in this set. That means even if you're able to find one A in this set A, which does not satisfy this thing, that means it's not a reflexive relation.
1 by root 2 doesn't come under real numbers.
It
What?
is real actually. It is there in the
1 by root
relation.
2, 1 by root 2 does satisfy this thing, but there are a lot of tuples that don't. For example, 0, 0. 0, 0 is in A cross A, but it doesn't satisfy what you
Yeah,
just
got
said
it,
is
got it. Got it.
you
Yes.
need
Ma'am,
it to
0,
be
0
true for,
doesn't
that's why this is
qualify the
important.
condition.
Yeah. Even if one
I
thing
was
doesn't
saying,
satisfy the condition, it's not
Okay,
reflexive.
got it, ma'am.
Same goes for symmetry and transitivity. Same the case there. So for
Ma'am,
symmetry,
ma'am, same if there is one pair which does not satisfy, so it is not
yeah.
symmetric and it is not transitive, even if there is one pair like
But
that.
yes. So even if you want this condition to be true for all AB belonging to this relation, you want BA to be in this relation. So whenever you see a pair AB in R, you just flip it and check if the opposite is also in R or not. For every
can you
pair
give
in
an
R.
example for symmetry?
1, 0,
Yeah,
and 0, 1.
and can you give an
We
example
can,
for symmetry so that we can
yeah, we
learn it
can have a look
more?
at this one.
Ma'am, I
So
guess this
the
is a
relation
symmetric.
is,
This is a symmetric
yeah, it
relation,
is.
ma'am.
It is. So the relation in the question given to you is x, y such that their square sum is, the first condition is they are from real numbers, and second condition is their square sum is 1. This is the condition, right? So let's just check this one only. If you say that your x square plus, so for x, y, let's just have AB here. So if I say AB belongs to this relation, that means a square plus b square is 1, right? And you have to check if BA belongs to, because if AB belongs to this thing, this is given. Let's say this is given to you, that AB belongs to R, and you have to check this. If this holds, then does this hold too? So for this to be in R, you want B square plus A square to be 1. So if A square plus B square is 1, this is given to you. And can you conclude that B square plus A square is also 1?
Yes, ma'am.
Yes,
It is.
ma'am.
Yes, ma'am. Yes, ma'am.
That's why this is a
Ma'am,
symmetric
when
relation.
you wrote R is equal to
Ma'am, for
x,
all
y,
examples, ma'am,
ma'am,
but
when,
like we have taken 0, 1.
Yeah, take
ma'am,
any example. If you take 0, 1, 1 second. 1, 0
One
is
of
also in R, no? If this is in R, 1, 0 is also in R. This is true for every AB in R. If AB is in R, then BA, the opposite is also in R.
Ma'am,
ma'am, what I was saying is when you wrote x, y, just left, just a little left, when you wrote x, y, this one, ma'am, this vertical line is the symbol of such that, na?
Yeah, yes.
Okay.
ma'am, if the specified set means we can able to verify this. If complete all the real number means, how do you verify all the real numbers? How
You
we can make
prove
sure
it.
that it is
That's why when you see, you don't verify for all real numbers, you prove
how
it.
do you make sure it is all real numbers are
When something is okay, when something is not symmetric, and same goes for reflexivity and transitivity too. Something is not symmetric, and you just need one example, right? One example to show that this is not symmetric. If you're able to find one AB in R such that this is such that, let me just write such that your BA is not in R, then this means R is not symmetric, right? That's what not transitive. Even if you're able to find one, you just need one example, only one example to prove that a relation is not symmetric. But to prove that it is symmetric, you need to show it for every in this case for every R cross R element, right? So we prove it here. How do we do this? If AB is in R, we need to prove that let's just say this is given to you. Given means this is true. So if this is true, you want this to be true, right?
Yes.
So you have to check this. You have to check if this thing is true, then this true as well. So this implies your A square plus B square is 1, right? And to check that BA is also in R, you need to prove this thing that B square plus A square is 1. Because you have been given this thing, that A square plus B square is 1, that means B square plus A square is also 1. That means if this thing is true, then this is also true. Is it clear now?
Yes, ma'am.
What?
Can you give any example of this? Instead of letters, you can give any numbers for make sure.
Do you want to do this?
Yes.
This example with numbers.
Yeah.
Okay.
Any numbers?
1
You
0
just
0
prove
1.
this, no? 1 0. If 1 0 is in R, that means 1 square plus 0 square is 1. And you need to check 0 comma 1 should be in R, which is true, right? Because 0 square plus 1 square is also 1.
What about 1 comma 2? It is not there, right?
So it's not there. Why do
So
you
then how
need
do
to
you
check
make
for every pair when you've proved it? The point of proving something is that you don't need to check for individual examples.
Yes, ma'am. I guess we can move forward.
If it's true for arbitrary numbers, if it's true for arbitrary AB, arbitrary means any real number. This is true for any real number belonging to AB. That means it's true for any real number. No, 1 0 is also a real number. It's true for that too. So that means this thing is symmetric. And then about the transitivity part.
It is not transitive, ma'am. It is not transitive.
For transitivity, you'll need the same thing here. If your AB is in R and BC is in R. So if
It
these
is
two are given to you,
transitive.
then your AC should be in R. This is what you have to check, and this is what is given to you. If or whenever this holds or this is true, then this should also be true for the relation to be reflected, to be transitive. Let's just check this condition. Let's say you've been given A square plus B square is 1, and B square plus C square is also 1. You have to check if A square plus C square is 1.
Yes, ma'am, it is.
It's not. Let's just take one example and then you will be able to see. Let's take.
Ma'am, this C
Is it?
square will eventually be equal to A square, right?
Ma'am,
Yes, ma'am.
you can put
Yeah,
A is
from these two
equal to 1
conditions.
1 ka square, and after that B is, suppose that B is your 2 and C is your 3. So
How
you
can you take
Ma'am,
2
A square is
as
directly
B?
equal to C square
1
here.
2 3.
You can take
We
2
take
as B.
another
Okay, one by
example
one.
of
No, ma'am, this is
Someone
not
has
relation
transitive.
quotient.
A is equal
Someone
to
has
1
an
and
example.
B is equal to
A
2 and
equals
C
to
is
1.
equal to 3.
A
B is equal
equals
to
to
2.
1. B equals to 2 does not satisfy this thing.
We can take -1, 0, and 1.
-1, 0, and 1. Okay. If you take A equals this, B equals this, and C equals to this, I think this is going to work. And your A square plus B square is going to be 1. B square plus C square is again going to be 1. Yeah. But your A
And
square plus C square is going to be 2.
This is not transitive.
Yeah, this is not transitive. So this is not a transitive relation. And
this is not equivalence also.
Not
it's obviously
This is
not
not also
equivalence relation
equivalence.
because, yeah, not equivalence.
Ma'am, what is the condition for equivalence?
The
One
condition is
second.
that they have to satisfy reflexive, symmetric.
Reflexive, symmetric, and transitive.
Acha, so it is not transitive, so that's why it is not equivalence.
Yeah.
This
Not
is not
transitive, and
reflexive
it was
also.
not reflexive either. Not reflexive, not transitive.
Yeah.
But for it to be not an equivalence relation, only one example is enough.
Is satisfy for all three.
Ma'am, just a small doubt I have, like just in the previous question, ma'am. Just a little
1 second.
two
Just
second
1
doubt,
second.
ma'am.
Yeah. Which one?
Yeah, ma'am, just the first question that we had. When you wrote in the right, there is A cross A, you said it's 9. Yes, ma'am. And
Yeah.
we have 137 elements. So A cross A is 9. So that would be 1 3 3 7 1 7 1 3, like that. Nine pairs we have in that way, na?
Yeah. Yes.
So A cross A is 9. That means we have one 7 pair. One pair is that. 1 3, one pair is that. Like that, na, ma'am? Yeah.
Yeah. 1 1, then 3. 3 is also there.
So like this, we have 9 kind of
This
pairs.
one,
Like,
and then take it. Yeah.
yeah. And in A we have 137. So root of 9 would be 3. So there are 3 numbers in A, like that.
Yeah.
Okay, ma'am. Thank you. Just that.
Okay.
Ma'am, can you explain symmetry part again? I have just taken an example of just one example, not contradictory examples.
I think in the next question there is
That's
the example. There is the next question is like that. There is.
Can we take another question
something
like
else.
that, ma'am?
Now we have another question here. We have one more question on reflexivity and all.
Ma'am, before moving to the next question, can you please explain equivalence class once?
Okay. So I'll just do it here. So for equivalence class, let's say you have an equivalence relation. Equivalence relation means it's reflexive, it's transitive, and it's symmetry. I'm not writing all of it, but it's all three of them. It combined together and gives you equivalence relation. I hope everyone knows what an
Yes.
Means,
equivalence
ma'am,
relation is.
it
For
will
equivalence
satisfy all
class,
three equations.
yeah, not equations, the conditions for
Relations,
reflexivity,
I'm sorry.
transitivity, and symmetry. So equivalence classes, basically, let us just do it with an example. That's not an equivalence relation, right? So let's take an equivalence relation. So let's take the relation of parallel lines. L1, L2, two lines are related to each other if they are parallel, right? So L1, L2, any two
Yes,
lines in your plane, and they are considered to be related if they are parallel. L1 parallel to L2. Let's just consider this relation. So equivalence class in this relation would be, let's just say you have been given a line 3x plus 2y equals 1. Then what are the lines parallel to this?
3x plus 2y equal to C, where C is element of R.
yes, ma'am.
Yeah, this type of equation, right? Where your a is a natural number and actually not equals to 0. Natural number minus 0. Right? And your c is any number. It doesn't matter. It could be any real number. So these type of lines are parallel to this line. So for equivalence class, what you do is, in equivalence class, you take the lines that are related to each other in this relation. So for example, if L1 is related to L2 under this relation, let's call it R, under relation R. If L1 is related to L2, then we say that it's L1 lies in the equivalence class of L2, or the equivalence class of L1 and L2 is the same. We write it in this, denote the equivalence class by this thing. There could be other symbols too. So equivalence class of L1 contains the lines L where L1 comma L is in the relation.
This is a symbol of equivalence, this bracket, square bracket kind of.
Yeah,
Ma'am, this is the part of
equivalence
straight line.
class.
This is the part of a straight line chapter.
This thing, yeah, it is a part of a different week, but I've just taken this as an example. You can take some other relation too. That's fine too.
Ma'am, this is the part
So,
of week 2, na? Week 2.
no, this is actually, it combines both concepts. It has some concepts from week 2,
Ma'am, when you have
parallel lines,
written
and then
L1 R, L2, what this R means here? R is a relation, na here?
related. Yeah, L1 related to L2.
Okay.
Under this relation R is defined here. So this, in simple words, equivalence class means the collection of all the elements that are related to L1. So equivalence class of L1 is the collection of all the elements that are related to L1 under this relation R.
That means
Okay, ma'am.
this equivalence has both symmetric,
Got it,
reflexive, and
ma'am.
transitive. All of the three are satisfied when you have written that in
They,
equivalence.
they will be satisfied because it's an equivalence relation.
Okay, ma'am.
Okay. Let's come to this question now. So you've been given in a college, there are 500 students. So total strength is given to be 500. Then 285 took mathematics, 195 took stats, and then 115 took English. And then maths and stats. Maths and stats means, so and means your intersection. This is the number of students that took both maths and stats. And this is for maths and English, it's 45. And for stats and English, it's 50. And then the students who took all three courses, that means maths, stats, and English, all three of them are 10. So if you look at the Venn diagram, it looks like this. This is the total college, 500 students. That means the total number of students here in this box is 500. Then we have maths, stats, and English, right? And there are some students, because they've given it here, what is the total number of students who took none of these subjects? So none of which of the area here represents none of these subjects?
Ma'am, complement.
What
No, the
complement?
complement.
Complement of
Yeah.
what?
The complement of the whole set. Like we can write it in the universal area. Universal.
The
Ma'am,
complement of this
those
thing. It's
yes.
Inside the box, but outside the circles.
Yeah,
And
outside
that is complement of A union B
in
union
the
C.
yeah,
universe area. Yeah, we can write that.
this thing it is. So you need to find the number of students that lie here in this region. And you've been given this thing. So you've been given all of it, right? So let's just first, for the intersection, you have this thing. If you have M, then your M intersection S intersection.
Ma'am, can you
Yeah.
explain it through the Venn diagram so that
Yeah, ma'am. Can you fill it all the values in
yeah,
those circles?
in the Venn diagram?
Individual like maths, stats, and English. That is, I think, more easier way to calculate.
There's
Yes,
a
ma'am.
formula
Yes.
for it. If you put it here, then that's why you have that formula that we have. M plus S plus E. When I'm writing M plus, I mean the cardinality. See this thing, and then you
Minus M.
have the
Ma'am, this
all
is
the three
complex when
intersections. So this is the easier way. Actually, if you look at this thing, then it will be more complex for you to figure out. And what we're doing here is we're trying to find this thing. M union S union E. We're trying to find the number of
Ma'am,
elements in this
after this,
union.
can you explain through it the Venn diagram?
Yeah, sure. So what we're doing here is, this is E. And this thing is M union S union E. And then you take the other intersection.
Plus
Then M
max
intersection
intersection.
S E. So looking at this diagram, you know that you need this thing, right? So how do you do this thing? You subtract M union S union E set from this entire universal set. This is the universal set, right? So you subtract the union of these three from the universal set to get the elements here, right? So here we have 500. We know the universal set has 500 elements, but we don't know the union of this. How many elements are there in the union of these three? So to find the number of elements in union of these three, we use this formula. That's why I'm saying it's not easier to use the Venn diagram here. This formula has been derived so that you don't have to uh, deal with the messy Venn diagram. This formula
Ma'am,
comes from the Venn diagram only. Yes.
in the lecture they told us ki calculate solve this problem to in the Venn diagram.
What?
Yeah, that's right, ma'am. In the lecture itself, that is said that you have to solve this problem through the Venn diagram because that is more easier way to solve this. And also we feel that the Venn diagram is easier for us.
Yeah, ma'am.
This formula is derived from the Venn diagram only. Even if you do it from Venn diagram,
I
you'll
get it.
ultimately come to this formula only.
But ma'am, please explain through it the Venn diagram after that.
Yeah. Okay. Just use this thing, and then now you just have to put values here. That's all. You know the cardinality of all of the sets mentioned here. This. All of it is given to you. You just need this thing. Just put these values here. Find the value of the cardinality of M union S union E, and then subtract it from the cardinality of U. Is it fine?
Yeah, got the formula. But ma'am,
Okay.
in the end, you added M intersection S intersection E. Why we have added? Why we are not subtracted?
Okay, you have this
Because
thing.
some of the things is double counted.
You
Okay.
take these two. You're
That's why I
taking the sum
guess.
of, let's say this is M, S, and E. You're taking M, then you're taking S. And what happens is when you take the sum of both of these, you count this thing two times.
Ma'am, 70 maths and states both contain 70.
Yeah, I am explaining the formula, this thing. Where does this come from? Because there are some
But in
students who feel that it's easier
question
from Venn diagram.
they
Yeah,
gave us, ma'am, maths and state, they both took 70 student.
okay, but
In
what we're doing here is we're trying to find the formula here. I've already written the formula. You just have to put the values here and solve it. The question is done. Now we're trying to have a look at how can we do it using the Venn diagram. Yeah.
Yeah,
Okay.
continue,
So
ma'am.
if you'll take the sum of these two, or if you'll club these two together, then this part is counted twice. That's why you subtract it one time from here.
in individual, ma'am, we need to calculate individual maths, stats, and English.
Yeah. First, let's do maths only. So if you'll do maths
Yeah.
only,
So maths is, so first of all, add maths and stat both, and math English and stat English, and common part of all of three, and after that minus all of those maths.
wait. Let's take M union S. This will give you M S minus M intersection S. Then you do the same for this thing. I guess. Wait, and we've written the
Ma'am,
formula
you
wrong
won't
here. Why
solve
has no
this.
one mentioned it?
No, ma'am. I'm saying
No,
that
this is correct.
you won't solve this problem.
Which problem? It's already solved. You just
Uh,
have to put the values here.
Ma'am, but in above questions you have solved it and you have explained it. But for this, you will just put the formula
Ma'am,
and
if I
ask us to solve.
request, I
Yeah,
think diplomas are waiting
if
for
you give
meeting.
if you give the little concept for this formula through the Venn diagram, as the it is described in the lectures also through the Venn diagram, so that we can like revise it. It will be revised by us.
See,
Ma'am, I
but
guess
Venn diagram will take too much time and it's so complicated.
That's why I was
ma'am, can we move
avoiding this
forward
here.
also, because it's we have only done two questions and we
Yeah.
have to maintain the pace also, because
Ma'am,
all
what
those.
is the answer of
Yes,
this
of
Yes,
question, ma'am?
for the
Ma'am, what is the
reflexive,
answer?
when
transitive,
you
and symmetric relation, which is also like very easy problem, and we have taken that much time for that. So why can't we explain this? Because I
Okay,
think this
because this
kind of
formula
questions
is
will be
used.
in the
Hold
quiz.
on, hold on, hold on.
Yeah, ma'am,
Because you
exactly.
don't really
Yeah, in
need to
lecture,
know
the
how it's
professor
correct.
told us like Venn diagram method. All questions they have been explained to in Venn diagram.
You will have to ultimately use this formula because this formula is derived using the Venn diagram only. What I'm going to do here is I'm going to derive this formula using Venn diagram, and it's going to take time.
Ma'am, can we move
Ultimately, you'll have to
forward?
use this formula only. Hold on. That's why
please
So,
we're
move
ma'am,
not
what is the
doing
forward,
that
answer of
here.
ma'am.
this
This is
question?
taking too much time.
Yeah, what is the answer of this question, ma'am?
You can calculate yourself,
Ma'am,
right?
answer. What is the
Hold
answer?
on, guys.
But
Numericals
that
is
it is not
given, you can
revised. That
calculate.
the concept of this
It's
question is
60.
not get revised. It's just the formula, and we can use the
The
internet
answer
and
is
derive this
60.
formula.
Answer is 60.
60. Okay.
Okay. Can we move on to the next
Yes,
question
ma'am, we
now?
can move
Yes,
forward. Yeah,
please,
ma'am.
ma'am. Please, ma'am.
Yes, ma'am,
Okay.
move.
So this is the next question where you've been given another relation, actually two relations this time, and you've been asked questions on that. So first relation is xy. So xy will be in relation 1. The condition for that is that this is the symbol. The condition for xy to be in R is the 7 should divide. This is the symbol for divide x minus y. So 7 should divide x minus y. That's the condition. And for the second one, this is for R1, and for R2, you have other questions visible. For R2, the condition is that the sum of these two should be equal to 2. And what's the set? To define a relation, we first decide a set, right? We discussed it. What's the set here?
It's an integer.
Integer.
Yeah, right. R1 and R2 are relations on set Z, set of integers. So you will have to check. We used to check for all A belonging to this capital A. This time the capital A is Z. You have to check for all A belonging to integers. First, you have to check for R1 be transitive. You want AB, if AB and BC are in R1, then you have to check if BC is, sorry, AC is in
AC.
R1 or not. So if you say that your B, what does this thing mean? This means your A minus B is divisible by 7. 7 divides A minus B, and 7 divides B minus C, right? This is what it means. Then
7 divide A minus 3.
you have been given this thing. This is given to you, and you have to check this, right? For transitivity, and you have to check if 7 divides A minus C. So I think we've done something similar to this in one of our previous lectures.
Yes, ma'am.
Yeah, we can skip this now.
I
Ma'am,
think you've done the
why?
same
Ma'am, may I
question.
explain this, ma'am? Explain.
Yes,
7
ma'am.
divide A
Yeah,
minus
okay.
C.
Just hold on. So you have to check this thing. This is what you have to
Ma'am, but
check,
it
and
will
this is
take
what you've
more
been given.
time because it is
Okay,
just
and you're
repeating
taking
that
even
last
more
question.
time. You're taking even more time. If we'll keep arguing
No,
like that,
ma'am.
that takes more time.
Ma'am, we have
Ma'am, but
sufficient more time, ma'am. You
that's
will
the
explain,
question,
ma'am.
ma'am. The last
Ma'am, explain
question we
it.
were taking is the only question on that concept, but it is the second question, and already you have taken that time for
Hey, don't fight.
giving the
Okay,
concept of for that
thank you
question.
for letting me know. And I've decided to do this question. This is because your 7 divides A minus B and 7 divides B
Yeah,
minus
ma'am.
C. So it divides the sum too, right? The 7, if a number divides A and a number divides, same number divides B, that means it divides the
Ma'am.
sum too, right? That means 7 divides A minus B and B minus C, the sum of these two. That means your 7 divides A minus C. That's what you have to check, right?
Yes, ma'am.
That means it is transitive. But the
Ma'am,
option says it's not
Ma'am, can I
transitive.
suggest, ma'am, can I suggest a kind of a formula for this? Because A minus B, there is one common 7. We can have one common 7, and from B minus C also we can take one 7 common. So when we minus them, 7 A minus B minus 7 B minus C, there will be a 7 common. So in that way also we can say that.
Yeah, we don't have to do all those things here.
Yeah, ma'am.
We're already short on time, so
Ma'am, can you put some example in A minus B and B minus C and A minus C?
okay. If you'll take, let's just say you have A equals to 7 and B equals to 14 and C equals to 21. Then 14 minus 7 or 7 minus 14 is minus 7. 7 divides minus 7, right? And if you'll take B minus C, that is minus 7 again. 14 minus 21 is minus 7. And 7 again divides minus 7. And you have to check it for A and C. So A and C is 7 and 21. 7 minus 21 is minus 14. The 7 divides minus 14 as well. You can take this example.
So ma'am, it is transitive.
Yeah, it is transitive, but the option says not transitive.
Okay, ma'am, we can move on.
And R2, the symmetry of R2. So for symmetry, you have, let's say your AB is
A minus B and B minus C.
I'm not writing the entire definition. This would mean that your A7, if divides A minus B, this is given to you, and you have to check. Your
7
to
B
check
minus.
now is B minus A.
Ma'am, this is for R2.
Yeah,
That is
this is for R2.
Yeah,
This is for R2.
yeah, A plus B
Okay, this is for
is
R2.
equal to.
All right,
Yeah,
the option
ma'am.
is for R2.
And ma'am, when
So
it is plus
for
x plus y is equal to constant, it will always be symmetric, na ma'am? Because symmetric, it's like that. It's well understood. Like I guess x plus y is equal to
even if
constant.
it's not symmetric, if there's some sum, if it says your x plus y is even, or if they're talking about sum, and that is a symmetric thing. 7, or if they say this sum is even, this sum is odd, something like that. If your x plus y is 2, this means your y plus x is also 2, right?
Ma'am, when the sum is constant, it will always be symmetric, na?
When the sum is constant, even when the sum is not constant, then also it can be symmetric. In fact, the sum ones are generally symmetric only, unless you change things entirely. And then this is true. R1, R2 is symmetric. And then R1 is also symmetric. We just discussed
Ma'am,
it.
example, ma'am, give some example.
Okay, let's take 1 plus 1. So if 1 plus 1, 1 is in R2, you have to check. Let's not take 1, 1. Let's take 2, comma 0.
Exactly, ma'am. One is the same.
Yeah, that's the same. So 2, comma 0 is R2. This is in R2, right? Because the sum is 2. And you have to check. And for this, you have to check. 0, comma 2 is also in R2, right? 2, comma 0 is in R2. 0, comma 2 is also in R2. And then you have the symmetricity of R1. For R1, if 7 divides A minus B, then this implies 7 divides B minus A as well, because B minus A is nothing but the negative of A minus B, right?
Yes, ma'am.
Yes, ma'am.
Just we'll get a negative quotient. That's all, but it divides in a way.
This is symmetric. And then we have the transitivity of R2. So let's just say, and okay, for transitivity of R2, let's say your x plus y is 2, y plus z is 2. These two are given to you. And you have to check if your y,
X
your x
plus
and z
Z.
Z.
is 2. So this will give you y, let's just take
You can take
x
1 plus
equals to 2
1.5.
minus y. Yeah, you can take examples, but this, I think, let's do it this way. Your x from here is 2 minus y, and z from the other side is 2 minus y again, right?
2 minus 1.
That is also 2 minus y. So if you take the sum of both of these, you get
2 minus y minus 2.
4 minus 2y, which is equals to 2. And this will give you a condition on y, right? Y cannot be anything. You have a condition on y. So here, from here, you'll get y equals to 2 minus 4, which is minus 2, minus 2. So you're going to get 1, I guess. Where y should be 1. You have a condition on y. But when you take this, you take x and y to be arbitrary. That means you can take xy to be anything, yz to be anything. But this is specifically true for y is equals to 1. That means it's not true for all x, y, z. Correct? Is it clear?
Yes, ma'am, it's clear. We can move forward.
The reason is we want it to be true for every, where is it defined? It's defined in a set of integers. So we want it to be true for every integer, but this is only true for y equals to 1. Whereas this should have been true for every y belonging to integers.
So, I mean,
Ma'am,
ma'am, whether it's symmetric, transitive, or reflexive, if even there is a one condition, the whole of the symmetric or transitive or reflexive, it negated, na?
Yeah, because when you have a condition like this, that means you can't take y to be any integer. There's a condition on y has to be 1. Even if you got y equals to 1, 2, 3 here, if you will get y can belong to set of integers, then this can be true, right?
Yes, ma'am, we
Because
can.
we're not violating any condition that's given in the relation. Here we are violating a condition. Condition in the relation says your y should be from integers. Here you've restricted it, and you're saying that it can only be 1. And remember that you want this thing to be true for all x, y, z belonging to integers in this case. But this is only true for x. There's no condition on x, z, but this is only true when y is 1. That's why there's a problem. So this is not true as well.
ma'am, in previous questions, like to disprove something, you took some example, right? I mean, which is not a transitive. So in that way, can you take an example for this XYZ pair?
Yeah, sure. Just 1 second.
Yes, ma'am.
If you want to take
There would be,
anything,
ma'am, there would be
take
one.
x, y to be anything. What?
Ma'am, can I suggest an example?
Okay.
Yeah, let her
Go
ma'am
ahead.
take, ma'am. Please go ahead, ma'am.
So you have x,
Ma'am,
y.
I'm asking, ma'am, why
We
do you
can take
always?
Yeah,
Yeah,
we
x
are
as minus
listening.
3.
We are listening. You are not the only student, no?
you are also not the only student.
Yeah,
Why?
80 students
Why?
are
No
there.
Tripoli?
80 students are
Ma'am,
there.
please
Don't fight.
mute the
No
mic of
argument,
Tripoli,
guys.
ma'am.
You mute the mic first.
You mute.
Don't fight.
I'm
Okay.
asking, ma'am. He always come in between
Yeah.
Tripoli, whoever he is. Mute
Please,
the mic.
no bullying each other here, please. Okay. So,
Ma'am,
yeah, we
we
were
were
doing an
about
example on
to.
it where you can
Yes.
take x, y to be anything. xz to be anything actually. Take xz to be anything because there's a condition on y, no condition on xz,
Okay.
right? So take these to be anything and take y to be something other than 1. Take y to be 2.
Okay.
Take x to be 1, z to be, no, you can't take x to be 1 then, right? If your y is 2, then you have to take x to be 0, right? So take x to be
Yes.
0, z also you'll have to take 0. Take this thing. Then the sum of x and y is 2. Sum of y and z is also 2, but sum of x and z is 0. It's not 2. Is it fine?
Okay, okay.
Okay.
Okay, ma'am.
Excuse me, ma'am.
Yes.
Ma'am, can I get the recording of this lecture after the meeting
Yeah,
ends?
it's there on YouTube.
Okay.
I'm
And
just, I want to take
someone
the screenshot
please
of the
share
last,
the
last, yeah, this one, ma'am. Yeah.
please share the link of the YouTube channel if it has not already been shared here.
Okay, ma'am.
Okay. So next up we have this thing where you've been given two lines L1 and L2, lines in plane, and x-intercept of L1 and L2 are given be 2 and -1. So let's L1 and L2, x-intercept is given to be 2. That means 2, 0 is on L1, right? And this is -1, 0. And the respective y-intercepts are given to be 0, -3 and 0, 2 as per the question. So you have to choose the point where L1 and L2 intersect. You have been given 2 points. Can you find the equation of L1 from here?
Yes, ma'am. That would be x by a plus, means x by 2 plus y by -3 is equal to 1.
Yeah, y by -3 equals 1. So this is of L1. And for L2, you have x by -1
-1.
and y by 2 equals 1. And you just have to find the point of intersection of these two lines. It's doable, I guess, because we have more difficult and complicated questions afterwards. I'm not solving the questions here. I'll just, because we're short on time, so I'll just tell you how to do the questions. Is that fine?
Yes, ma'am.
Yes, ma'am. Yes.
Or so what you do here is write y equals to write line L1 in terms of y equals to something. So separate y from here with coefficient 1. And similarly from here, separate y and write it in terms of x. And then you equate both of these expressions to find the value of x. Is it fine?
Yes,
That's how
ma'am.
you
Yes.
find the point of intersection of two lines.
Yes, ma'am.
Or two curves for that matter. Moving on to the next question. Okay, so this is the next one. You have been given a triangle ABC. This is A, B, and C. The coordinates A, B, C are also given to you. And then you've been given another coordinate P, P and T square form. This coordinate has this form. And another triangle given to you is PAB. So PAB, this triangle. One triangle is this one, and the other one is this one. These two triangles are given to you. And then they're saying that the area of ABC, area of triangle ABC is 4 times
Name
area
this
of triangle.
points in any order, is it, ma'am?
What?
You've taken A, then B and C. And we can
Yeah.
name it in any order, is it?
You can take them in any order.
Okay.
Okay. So this is given to you. And that so you don't actually need this condition because they're not asking you the area of this thing. They're not asking you the area of PAB, they're just asking you the area of ABC, this triangle only. And you've been given the coordinates for which you have a simple formula. Given the coordinates of a the coordinates or the vertices of a triangle, you can find the area of the triangle, right?
Yes, ma'am.
You have a form. You have this formula for it.
X1 into
X1
y1, y2 minus y3.
y2 minus y3 plus x2 into y3 minus y1. Okay, so into y1 minus y2.
use this formula you have been given. You can consider it in any order. Consider this to be x1, y1, x2, y2, x3, y2, x3, y3, or you can go in this order too. Doesn't matter.
Okay, ma'am.
Ma'am,
Ma'am, in
but here
the
we should follow the anti-clockwise direction
yes,
always,
ma'am.
right?
It
Like
really
we
doesn't
can,
matter because if you even change it, I don't think it's going to matter.
the area would be
Anti,
same,
if you're
right, ma'am?
talking about in this, what I'm trying to say here is in anti, don't change the formula. Keep it as this only. Else you can take if you're calling x1, y1 as first coordinate, x2, y2 as second coordinate, and x3, y3 as third coordinate. Then you can choose this to be 1, this to be 2, this to be 3, or this to be 1, this to be 2, this to be 3. You can choose it in any order. You're going to get the same area.
So,
Just don't
ma'am,
mess with this
to
formula.
calculate the t, right? T in comma t square.
You have not been asked to find t. But if you've been asked to find t, then what you do is use this formula for this triangle and the same formula for this triangle. Right? And put it here. And you will have a quadratic equation in mod. So you will have something like this. T minus t square plus t minus, you'll have some things like this. And then you'll have a number here for this
Okay,
one.
fine.
So you just have to solve this thing.
Why need to
Waivers we
calculate
can
this, ma'am?
multiply to 4.
What?
A, B, C coordinate are given, ma'am.
Yeah, ABC coordinates are given to you here.
Directly we can able to calculate the
Ma'am,
area of the
directly we can solve the area
Yeah,
of
directly we
triangle
have to
ABC.
find.
Yeah, if you can this question doesn't ask you to find t, but you can be asked to find t, right?
Asking the area of triangle ABC, ma'am.
This question only asks you to find the area of ABC. For this, you don't need this thing.
Ma'am, one thing, when we
Just
remove the
use this
mod,
formula.
we have plus minus, so we can have
Ma'am, we
both.
can
So
solve it directly from determinant method as well, taking up one extra.
what?
Determinant method.
This is the determinant method for areas. It's the same thing. You use the determinant method or you use this formula. They are one and the same thing, written in different manner.
Okay, okay.
Ma'am, I was saying when we remove the mod, we get plus minus, so we can get two
Yeah,
values of t na.
you will get two values of t, but okay, if you will put this thing, let's just say you have this thing, and then you find you solve this thing, 3 minus t square, or whatever this thing is, you solve this thing with a plus 1. You'll get something. And then if you'll put it here,
Ma'am,
you're
can you
going to
repeat
get
how
two
to
values
find
of
T?
t.
And how you find T as 3?
Can you
Okay,
repeat it
what you
again,
do
ma'am?
here is, to find t, what you do is, area of ABC you can find from this formula, right?
Yes,
And then
ma'am.
for area of PAB, you also use this formula again. But here you'll have a variable, which is coordinates of PR in terms of t. So you'll have something like 4 times 3 minus t. I'm not sure what you're going to get. 3 minus t square. I'm just writing random things. It is something in this terms only, right? You'll get something like this here. And then half here. Half this thing. And then this will be equal to the area of ABC. Let's just say your area of ABC is 1. And what you do is you remove this mod, but for that you'll have to put plus minus here. So for 1, solve it for plus 1, remove the mod, t minus t square plus 0 minus t. Let's just say you had this thing in mod, solve this thing, and then for other one, solve this thing. And find the values of t from both of these things. So you
Area
get
will always
two
be only positive,
tuples
ma'am.
then.
Just take whatever is
Okay.
positive.
Then we might get 4 values of t if
No,
So
area will
you're
always
only
be
going to
only
get,
positive. So take only positive values. So
yeah.
can't be negative.
I guess we should not go for T.
They're not going for T. You're not, if ever you're asked to find T in this question, then you have to do this thing. Otherwise, in this question, you don't need to find T. Is it fine?
yes, ma'am.
Ma'am, I guess we should not go for T as coordinates of the ABC are given there, no?
Yeah. You don't have to go for it. We were discussing something else. The question. Okay. Coming to this question.
So, ma'am, are we getting 4 values of t from this or 2 values only? Just asking.
I don't know. This is not the question. I've just told you if something like that is given, that's how you have to solve it. And then you just have to check the constraints if it satisfies everything. Some of the T's might not satisfy the conditions. And we move on to the next question. We can come back to this later and then we'll try to find T. Is it fine?
Yes. Yes.
Yes, ma'am.
Yes.
So, then you've been given this question where just by looking, you don't even have to read the entire thing. You just have to know which one is X and which one is Y. So this thing is Y, right? Given to you in the question. Amount paid is Y and the distance is X. And then how do you find the sum of squared errors? Make a separate column here. And find the value as per this equation, right? So put X here, where X is 20. If you put X equals to 20, we'll get 20 plus 81. And then if you'll put 15 here, you'll get 61. And if you'll put 16 here, you'll get 65, I guess. Do the same for everything. And then you'll get, is there a doubt?
No.
And then just subtract this thing from this. Or you can do either way, 80 minus 81 square or 81 minus 80 square. Because it's square, it doesn't matter. And then 61 minus 60 square. And then 65 minus 60 square. And rest we have not found yet. So I hope you can do this thing, right? And then you find the sum of squared errors. Is that fine?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
One slight modification that can be done to this question is instead of giving you in the question to find the sum of squared errors, you can be given to find one of these values here. It can happen that one of these values are not given to you. And instead of this, you've been given sum of squared errors. Let's say you've been given your sum of squared errors is 100. And this value is missing. That can be some change in this question. And how do you find this value here? Do you understand the question?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Equate those values to the SSC.
Yeah. So what's going to happen this time is instead of this, now you have
A quadratic, you have to find the minimum of about it.
so you don't have to find minimum and all. You can just solve this equation. This one. So now you've been the sum
Oh,
of
the
squared
SSC
errors
is
is
given
given to
there.
you this time, no?
Okay, okay.
Yeah, this is given to you.
Ma'am, then though we will
This is
have
given to you.
2 values of kind of because plus minus will be there. So
Yeah, you will have two values and you'll then there'll be options given to you to eliminate one of them. There'll be no question with two values and that's not going to happen. Can we move on to the next question?
Yes, ma'am, please.
Yes, ma'am.
Okay. Next up, we have this question. Is it visible?
Yes,
Okay.
ma'am, it is.
So, What is the condition for parallel lines? Condition on coefficients?
M1 equal to M2.
Slopes are
Slopes.
Yeah, slopes are, yeah, you can say that too. The slopes are equal for parallel, and for perpendicular,
M1 into M2
M
equal
into
to
M2
minus
is
1.
equal to -1.
you just have to check these things. What's the slope of L1?
Minus 2 by 3.
Yes, -2.
Yeah, right. Minus 2 by 3. For L2,
-3.
Minus 1 by 3.
Minus 1 by 3.
it's
Minus
minus
1 by
1 by 3.
Yeah, -1 by 3.
And for L3,
Minus 1 by 3.
-3.
Minus 1 by
minus
3.
1 by
Minus
3, right?
1 by 3.
So these two are same. So L2 and L3 should be parallel. And the product is never minus 1, right?
That's all. Nothing else.
Second option is correct.
Yeah, the second one's correct. L2 and L3 are
D
parallel.
we have to, D we
L1
have
and
to
L2.
confirm, no?
What?
D we have to confirm, no, ma'am. L1 is equidistant from line L2 and L3.
I don't understand what you're
Ma'am,
saying.
option D we have to find out. That's what he's saying.
Okay. L1 is equidistant from the line L2 and L3. So to check equidistant, we've been given some lines. This is, let's say, L1, L2, and L3. To check if L2 and L3 are equidistant from this line. To find the distance between L1 and L2, how do you find? There's a formula for distance between lines.
Yeah, mod of C1 minus C2 by A square plus B. Square root of A square.
Is it?
for parallel.
Mod of C1 minus C2.
Ma'am, I don't think it
Yeah.
would be equidistance because L1 and L2 and L3 are parallel. So if there is a line L1, any which is not parallel to L2 and L3, so it won't be equidistance in any ways.
Let's not make assumptions, right? Let's just try to solve it using the distance formula. There is a formula for distance between two lines. There, let's just say
Mod of C1 minus C2 by root of A square plus B.
C1 minus C2 by root of A square plus B square, where
And
the
A
two
and B should
equations
be
are
same for both the lines.
C1 and
AX plus
AX
BY,
plus
ma'am.
BY. Yeah, sorry.
Plus
These
C2.
are the two lines. So these are two lines, and the distance between them is this.
The lines are parallel, ma'am.
Ma'am, this is the distance formula for two parallel lines, right?
Yeah, parallel lines only.
Okay, so how
For
can we
parallel
find the
lines,
distance between any two lines which is not parallel? Is there
okay,
a
let's just say you have a plane, and then either two lines are parallel, or the distance between lines actually means the distance here. Right? The shortest distance between two lines. That's what it means. For parallel lines, it's always the same. But for there are only two cases. In plane, either your lines are parallel or they're intersecting.
Yes, ma'am.
So if they're intersecting, because we know that L1 and L2, you have to check the distance of L1 from L2 and L3. L1 from L2 and L1 from L3 actually should be equidistant because both of them will be 0, right? For
Ma'am,
lines intersecting, the distance is considered to be 0.
Yes, ma'am.
So what was the point you said?
yes.
Last point
So
that you made, which you eliminated the option D?
Okay,
ma'am, I think
L1,
we can find the
L1 will be
distance.
equidistant only if it is parallel to L2 and L3. Since L1 is not parallel to L2 and L3, it cannot be equidistant.
So, ma'am, according to this, you are saying that the distance would be 0, right? If they're intersecting.
yeah,
And
that's how it should be.
and L1 will obviously intersect with L2 and L3 because it is not parallel.
Yeah.
Then the option D would be correct, right? And the distance would be 0. Is it, ma'am?
It should be like that.
I think
But this option has been marked incorrect.
okay. I think there is
Ma'am,
not
it's
any
because L1
specific.
is not parallel to L2, L3. That is why it is
But
incorrect.
There is not any
Equidistant will only
specific
be
formula.
if it is parallel to L2 and L3. Otherwise, it cannot be equidistant.
Ma'am, there is not any specific
since
formula
this
for
in
distance between two lines if they are not parallel.
general, if two lines are not parallel, they are considered to be intersecting. And the
Mhm.
distance between intersecting lines is considered to be 0. That has not been taken into account here. I think we're not doing the other case. In this one, so for your course, you just have to remember that the distance is only possibly can only
Ma'am,
be calculated when two lines are parallel.
okay.
And because these two lines are not parallel, so that's why we're not considering them to be equidistant.
L2
what
and
will
L3 are parallel, right?
L2 and L3 are parallel, but L1 and L, you have to check these pairs, L1 and L2 and L1 and L3. Right?
Then yes, ma'am.
And they're not parallel to each other. So,
So if
Ma'am, they
they're
are not.
parallel to each other, then we have this chance of the lines being
Yeah.
equidistant, but we cannot surely say that they are equidistant, right?
yeah, then you have to,
Ma'am,
if they are given to be, if in case this is parallel to this and this is also parallel to this, then you find this D. And check if both the D's are same, the D for this one and D for this one. And if it turns out to be same, that means the L2 and L3 are equidistant from L1.
Ma'am,
But in this case, yeah,
I just confirmed with ChatGPT and all. It's saying option B is correct. The rest are wrong.
this is incorrect.
Yeah, only option
Ma'am,
B is correct.
ma'am, I still didn't get. I mean, it is incorrect, but like
What
how
you didn't get?
the distance between L1 and so option wise, like whatever we are getting the distance between L1 and L2, that should be same with L1 and L3, right, ma'am?
Yeah.
So the distance should be 0 because
But
L1.
we generally consider the distance between intersecting lines to be 0, but there is actually no distance, because when there are parallel lines, what happens is when you
Yes,
take the distance between two corresponding points, it's always the same.
it is always
Right.
same. I
But
got it.
in intersecting lines, it's not same.
There is not any concept of distance, right, ma'am?
Yeah. So here
Then
yeah.
why it is given in option? I mean,
Confuse us, man. That's all.
yes, ma'am. This option should not be there, right?
Could be there if L1, L2, L3 are all parallel.
Because this
What if we
option
are
is related to distance, right? So
correct? But
That is what. If
But
L1 was
technically, we can't
parallel,
give this question.
then the statement is correct. If L1 is parallel to L2, L3, then L1 is equidistant
Have
from
we
L2, L3.
calculated the slopes? Okay.
ma'am, we might have a point as L1 and like we can consider L2 and L3 are same
L1
line
is
or
not a
not.
point. L1 is a line. If it was a point, they would have mentioned a point with
If it
coordinates.
is a point also, then L2 like unless L2 and L3 are same line, it would not be the
No, if
equidistance, I guess.
L1 is a point,
what
then
if it's on
it
either
can be
side?
equidistant. No?
Yeah, either side, correct.
Okay.
It can be equidistant then. Okay, can we move on to the next question if this one's
Yes,
clear?
ma'am.
Yes, ma'am. Yes, ma'am.
Okay. So this one is the next one.
Ma'am, just one thing.
Next one.
If two lines are
Yes.
coincidental, they are considered to be parallel, na?
Yeah, they are considered to be parallel. In that case, the distance will be 0.
Okay, ma'am. Thank you.
Okay. So, and in this question, you've been given two equations, two polynomials you've been given. Which of the following you've been asked which one's correct? So px, if you'll add px and qx, because you just need the coefficient of the highest power, right? So if you'll add these two, you'll get 2x cubed. So if x tends to infinity, or if in this one, if x tends to minus infinity, your 2x square tends to
Minus
infinity. Infinity, ma'am.
yeah, this tends to infinity. So this one should be
Good.
correct.
It's
Wrong.
2x cube.
Wrong.
Ma'am, there
X
is
cube is here.
Ma'am, first option is wrong, na?
Okay.
It's plus
You
x
add
cube.
both of these.
Plus cube.
It's
Oh,
a
this is
cube.
cube. Sorry.
Yeah.
yeah, cube.
I thought it's
Minus
square.
infinity will tend to minus infinity.
This one's cube. This one's also cube. Minus infinity then. This one's incorrect. First one's incorrect. Then px minus 2x.
But you have minus 3x.
So the highest coefficient, we'll just write the highest, the coefficient with highest power.
Minus
So this
3x
subtract
square.
Second option is correct.
Correct,
ma'am. Second one is correct.
the highest power will be this minus 3x square. And if your x tends to infinity, minus 3x square tends to minus infinity.
Right.
So this one should be correct. Then 5px. So the highest degree coefficient
Wrong.
will be 5x cube for px, 5px. And if your x tends to minus infinity or 5px
Wrong.
is going to tend to minus infinity. I don't think we need to do the last one. You can do the last one, right?
Yeah, it's right.
Yeah, last one is correct.
Okay. We'll move on to the next question then.
Ma'am, can you go to the previous one? Minus 3x square. Minus 3x square. It is x square, even degree. Both it will be minus negative.
We have a negative here.
Minus infinity. Okay, got it. Got it. Sorry.
You have this thing. You've been
Ma'am,
given a
this
polynomial
question
and you've,
I have problem. Please explain with a graph if possible.
yeah, we'll do this. The first part is very easy. You just have to find the degree, and the degree is from here you get degree 8, here you get 3, and here you get 5. So the total is 16, right? I hope the first one is clear.
Yes, ma'am.
Okay. And then for the second one asks you to find the number of turning points. So let's just draw the rough sketch of this one, px first, right? So you have minus 12 here, minus 4 here, and 4 here. And you know that if your x tends to, let's check this thing, if your x tends to infinity, your px also tends to infinity. Or it tends to minus infinity actually. It tends to minus infinity. And if your x tends to minus infinity, your px tends to minus infinity again. That means it should be like this. Is it fine? This thing for sketching the graph. And then you have this thing. So if we have a look at the first factor, you have x, the degree is 8. Is 8 here. That means it doesn't cross it. It comes like this, right?
Ma'am, at minus 12, the degree is 5. So
Oh,
the
sorry.
multiplicity is
Ma'am,
5.
it
Sorry.
will cut. It will
Cubic
cut.
Yeah, it's 5 here. I thought it's 8. Okay. This is going to cut because the degree is 5, right? And
It's
then
like
at
cubic, right? Cubic.
no, nothing's cubic. This one is not
That
cubic. It's of degree 5.
Yeah, like I'm just asking, like in cubic we have, that shape. What we.
ma'am, it
Correct,
will
ma'am.
cut
Yes,
in a
like
different
cubic one.
manner. I mean,
Ah.
not in a straight line manner.
Yeah,
It doesn't
it's
matter
band
how
between
it
that.
cuts. It's fine.
Yes, yeah, yes, ma'am, it is fine.
But just plotting the rough sketch of it, it might change. So, and for this one, for minus 4, 1, we have this. And the degree is 8. This one's not going to cross it. This is this, right? And we'll have to have a turning point here. Note that you'll have to have a turning point between minus 12 and minus 4. Because it's a continuous function, right? So you should
Yes.
have a turning point here, at least one turning point. There could be more than one. We don't know, but there is at least one. It could be like this. Minus 12, minus 4. It could be like this thing.
But
Right.
how do we know if it is like that? There is
Yeah, we'll come to that later. Right now, we're just doing a very rough sketch of it.
But why it's not crossing -4? That's I'm not understanding.
This factor, you have the factor x plus 4 to the power 8. Because it's even degree, that means it doesn't cross, it just touches and passes.
Even
So it should be
multiplicity.
like this. Yeah, this is because of the multiplicity.
Yeah, but it could be like it will cross -4 and it will again go up and go to +4 like that.
Okay.
No, it's for even multiplicity, it's always
Okay,
like this.
can you
Touches
check?
and passes.
Uh,
And then for
Ma'am,
this one, yeah,
ma'am, from point -12, why it is coming down, ma'am? I have not understood that.
this one,
Yes.
it's because of this thing. When your x tends to minus infinity, yeah, your px tends to minus infinity. That means if your x will go to minus infinity, your y will also go to minus infinity. This is how your y goes to minus infinity. This is how your x goes to minus infinity.
Yeah. When x tends to
But the
increase in negative
coefficient,
direction.
we have it as negative here.
Yeah, that's why it's opposite, right? If you have minus infinity here.
Ma'am, if x tends to minus infinity, p of x should tend to infinity, right? In that case.
No, no, ma'am, minus
This
infinity.
will be positive. This, because your x are negative. So this will be negative. Both of these are negative and this is negative again. So 3 times negative is negative.
Ma'am, in lectures
Here,
it is shown just opposite.
My doubt was you told if x is tending towards minus infinity, p of x is also tending towards.
And your x is negative. That means this term is positive. This one is negative. This one's again negative. So you have negative 3 times. 1, 2, 3. So I have negative, negative, and then negative. That means this entire thing will go to minus infinity.
Yes, but sir has done it opposite way in lectures. Can I share the photo?
No.
It must be a different
The
question
end
then.
behavior, the end behavior.
Yes, not in this
pretty much
question, but
one
the
set
question is.
If it's
Sorry,
is there a problem with this approach?
No, ma'am.
ma'am, I think you are correct, but in lectures it is shown incorrect, I think. Can I share the photo, ma'am?
Yeah,
Ma'am,
please.
it can be done in discourse.
Yeah, you can put that there in discourse.
Ma'am, this is perfectly
I'm
fine.
only.
I think we are on a perfectly fine path. We can.
This is
But
it.
I'm not able to understand like how you are like
Okay.
doing. That's the problem.
This is a very rough diagram. What we're doing is first we plot the roots, and then when your x tends to infinity, this is x tends to infinity. Your y tends to minus infinity, right? So it should go down. And when your x tends to minus infinity, your y again tends to minus infinity. That means it should again go down here. Is this part clear? Both these things.
No,
And
ma'am.
at minus 12,
Hello.
does anyone have a doubt here in this thing?
Yeah, no, this is clear, but like next one.
Okay.
-4.
At minus 12, because the degree is 5, it's an odd degree, so it should cross.
This is clear. -12 is clear. -4 is
At
not clear.
minus 4, which one? Minus 4?
Yeah, -4. Why it's not crossing? That's my question, because I know this is quadratic, because this is what do you say? You know, positive
even
number.
degree.
It is even
8,
number.
man. Multiplicity is 8.
We don't have time for
in boundaries.
discussion left. We don't have enough time left. So, and we have a lot of
Okay.
questions left.
Okay, well, let's proceed then.
One doubt alone, you said it can have multiple turning points between -12 and -4. Why
Yeah,
here
we'll
it is
come to
only
that.
one?
We'll come to that. Wait.
Yeah, that alone, please.
That's why I said this is a rough sketch. Very rough. So this is it. Is this much clear to everyone? You have this turning here. You don't cross it here because it's an even power here. 8. That's why you don't cross it. And here you have an odd power. That's why this crosses it. This is a rough diagram. Now, we have degree 16 here, right? The degree of px is 16. Let's come to the derivative then. So degree of p dash x is going to be 15, right? Is this clear to everyone?
Yes, ma'am.
Derivative cancel आ रही मैम.
That means if you have, what And what does the root of p dash x mean to you graphically? And your p dash
Number of friends.
It can be a turning point, right?
Yes, ma'am. It can be a turning.
That means, and what happens there is this is roots of p dash x counted multiplicity. So the multiplicity is counted here. It doesn't mean you have 15 different roots. It
Okay,
means
okay.
you have roots and they can be repeated. If you have 3, 4, and 5 as roots, then 3 could be repeated 5 times, 4 could be repeated. You're getting my point, right?
Okay, ma'am. Then we can
And the
say that
total will be
like we can have at most n-1 turning points, right? If the degree is
n
n.
minus 1 turning points.
Okay, ma'am. Okay.
Ma'am, just I wanted to know the significance why you have written that degree of p dash x is equal to 15. What is the importance of this?
It's the same as n minus 1
Okay.
thing.
Anything
You say
else,
that
ma'am?
you have n minus, no.
Ma'am, you said the roots. That doesn't mean the roots of p dash x. What was that thing?
Okay, the
The
turning
roots
points
of
are the
p
roots
dash.
of p dash x.
Okay, ma'am.
The turning points that you get here are the roots of p dash x.
Okay, ma'am, I got it. So the turning points are between -12 to -4, -1, 4, between -1 to 4, right?
Yeah. And let's just come to the derivative. One thing
Yeah.
that I need you to know is your turning points are, all turning points are. So if I say that your x1 is a turning point, this means your p dash x1 is 0.
Then what is P dash, madam? Sorry, it might be a
P
basic
dash is
question.
the derivative of p. And I'll tell you how to find it. You have been
P
given
dash
this
is
one.
just a slope. So you're saying at x1 the slope is 0.
Yeah, the
Yeah.
slope is 0. You
It's
can say
flat.
slope, you can say
180.
derivative,
Correct.
both correct.
Slope is 0. Yeah, at this point we understood. What's the next thing you're saying?
So the equation, this is x plus 4 to the power 8, x is next, x minus 4 to the power 3, and x plus 12 to the power 5. This is your px, right? And then when you'll find p dash x, what happens is, how do you find it? For these three, uh, I know you guys are not familiar with this thing. Let me just do this. If you've been given fx, gx, and hx, let's say, then how do you find the derivative? Derivative is this thing, which helps you find the slope. So this is your derivative. So you'd need f dash x. So the derivative of this entire thing is f dash x, and you keep these two constant. So keep these two constant, take the derivative of this, then keep these two constant, fx, hx as constant, take the derivative of g, and then take the derivative of h and keep the other two constant. Constant means same, keep them same. Is it fine? So the derivative of this thing is this.
Yes, ma'am. It is. Ma'am, but the
For the
other
derivative of
way.
this, yep.
Okay.
Let me just do it first. For the
Okay.
derivative of this thing, you will have
8
minus x plus
x
4,
plus 7.
7, and then you will have these two things as same, right? And this one you will have 3, x minus 4, and the other two same. Where?
Whole power 2.
And then 5x plus 12 to the power 4, and the other two same. So when you solve this thing, you take these to be we have this as p dash x. Now let's just take these things common. From here you will have x plus 4. So you have x plus 4 to the power 8 here as well, right? And x plus 4 to the power 8 here as well, because you've kept it constant, right?
Yes, ma'am.
When you will take common, you will have x plus
7.
4 to the power 7. Similarly, from here you will have x minus 4 to the power 2. And from here, you will have x plus 12 to the power 4.
4.
And then you will have something here. You just call this thing qx. Is this much clear?
Yes, ma'am.
ma'am.
Okay. That means the root here, how many roots are going to be here? It's 7 plus 2 plus 4. So in total, you're getting 13 plus the roots of qx, right? But we know the total number of roots of p dash x are 15, right? Because the degree is 15. The total number of real roots, or you can say maximum total number of real roots, can be 15. And 13 you've already identified, right? Is this much clear?
Yes, ma'am, it is clear.
13 roots are 4, minus 4, and minus 12, counting multiplicity. This is very important. You've counted the multiplicity. Otherwise, these are just 3. So what can happen now is with the other 2 roots, you have 2 roots left, right? They can be either complex, both complex, because complex ones appear in pairs. So both complex or both real. Are the cases fine?
Yes, ma'am.
It cannot be either.
Yeah, it's either. Either you can have both complex roots or both real roots. How
No,
can they do?
one complex, one real, like that.
No, that can. How can you have just one complex root? Because they appear in conjugates, right? If a plus iota b is
Got it.
implies a minus iota b is also a root. That means either you can have 0 complex roots or 2 or 4 or 6, right? So either both of the roots, the left roots are real or they're both complex. Okay, and let's just come to this graph then. I've made a rough diagram, right? Rough graph. It says, yeah, what does this mean? That at this point, at x equals to this point, the derivative is 0, right? This means that p dash x is 0 at this point. At x equals to this, your p dash x is 0, right? And at x equals to this, your p dash x is again 0. Is this fine?
Yes, ma'am.
Okay. Because these are slopes. P dash x represents slope, and slope is only 0. So when you have parallel line here, then the slope is 0. Because you have parallel lines here, parallel tangents to these points, that's why the
Yeah.
slope here is 0. So now you
Yeah,
have
0
two,
degree.
you have 2 points other than 4, minus 4, and 12. Minus 12 that have, at which you will get, so at this point, let's call this x1, let's call this x2. That means that x1 and x2, your p dash x should be 0, isn't it?
Ma'am, how 15 real roots?
Because the degree of p dash x is 15. Or you can say n minus 1, you can do the n minus 1 thing. 16 minus 1. So at most you can have 15 real roots. Out of
Ma'am,
which 13 we've already figured out from here.
But ma'am, roots are repeated. The same roots are repeated, right?
Yeah, that's why. Otherwise, we only have 3 here. Counting multiplicity, you have 13 roots.
Ma'am, but the other 2 roots, we cannot comment on their nature. They can be complex and real. They
Yeah,
can be either
we'll
complex or...
find. Yeah, that's what we'll show that they're real. I'm coming to that. So x1 is, and you see that x1 and x2, both of them are not equals to minus 4, minus 12, and 4, right? This is point x1, where your p dash x is 0. This is point x2, where your p dash x is again 0. But these are not minus 12, minus 4, and 4. Is that right?
Correct. Correct.
yes,
That means you have 2 different roots of p dash x other than these ones. And then you have this 2. If you had, and we've just seen, that means these 2 can't be, these 2 are real, right?
yes, ma'am.
Because we can match them on a number line
Who
of
are these
x-axis.
ones?
Therefore, they are real, is it? Because we can plot them on the x-axis.
Problem here is that your -12 and 4 are of
Ma'am,
odd
your voice is cracking a lot actually.
Yeah.
no?
Yes, ma'am. Your
You
voice
can also check
is
it from here.
breaking, ma'am.
-4 and 12 are of odd degree.
And
So
voice is
they can't be
breaking.
the turning points. So if you have turning points,
Now it is okay.
Ma'am,
okay,
your
if you
voice
have
was
roots, is it better now? Is
yes,
it
ma'am,
better?
it is better. It is
Is it
better
clear
now.
now?
Yeah.
Ma'am, just simple. So last thing I want to ask you.
Can
Hello?
you repeat the last point that you said because it was cracking, your voice was cracking.
Yeah,
Last two,
okay.
three
Just,
sentences we missed it
am
completely.
I audible now?
Yes, ma'am, you are audible.
Yes, ma'am.
Just 1 second. Let me just take.
Now again, ma'am, you are not audible.
-4 is also a root of
Ma'am, your
-4 is
voice is
a
breaking
root
again.
is the root and -12 is the root.
Ma'am, your voice is very much
All
cracking.
are not turning points. Only -4 is a turning point, right?
Madam, your voice was all breaking, so nothing was clear.
Yeah, ma'am.
Am I audible now?
Yes, ma'am,
Yes.
you are audible.
Yes, ma'am.
Okay. We were discussing this thing. -12 is not a turning point, neither is 4.
You have
Only
not
-4 is
shared
a
your
turning.
screen, ma'am.
Okay, just 1 second. Okay,
Now
so
it's visible.
these two are not turning points. This is a turning point, right? And we know that we can have at most, so 13 roots are already being discovered. These 4, -4, and -12 consist of these 13 roots. They're repeated, right? -4 is repeated 7 times, 4 is repeated 2 times, 12 is repeated, -12 is repeated 4 times. So this consists of -13 roots. And then you're left with 2 roots. You're not sure if those roots are complex or real. If those roots are real, then they contribute to the turning point. If they are real roots, then it's a turning point. If it's a complex root, then it's not a turning point, right?
Ma'am, why so?
Yes, ma'am.
Because if this is the numbers that you mention here, no? What happens is the only reason why p dash, let's say you have p dash t equals to 0. The only reason why your t is not, this is not a turning point is okay. This bit is clear, right? Both roots are real. Why? Because we have both roots here, x1 and x2.
Yes.
Wherever you see
Ma'am,
this
I
thing,
have a
whenever your
These are
t is
turning
0,
points, right? These are not roots, but
yeah,
turning points.
So,
these
ma'am, we
are
can say
turning
that
points, and they're also roots of p dash x. They're roots of p dash x. This and
Okay,
this
okay.
is the root of p dash x.
Ma'am, for it to be a real root, it should pass through the x-axis, isn't it?
ma'am,
Yeah,
we
the
can.
real roots you can represent on the real line.
So that's why it's a
Yeah,
real
so
root.
from the graph
Oh,
here,
let me complete first.
oh,
Let me complete first. Now, I expressed a possibility that your graph can look like this too. These two are roots. This is also a root. So your graph can look like this too. This was our problem, right? But that's not possible
okay.
because if this turns, that means this turns 3 times, right?
Okay.
If this happens, then it's going to turn 3 times. But you only have 2 roots for p dash x. Is it clear now?
Okay, ma'am, just one thing, the graph that you have made, where
Let
that the
me just
graph.
do it here again. It was like this, I guess. And we had a possibility this because this was a rough sketch. Our problem was either it looks like this, or this is also possible that it turns twice and then goes back and then turns twice or thrice. I don't know how many times, and then this can happen, right? This was our problem, main problem. But now this cannot happen because if you'll have, let's just forget about these things. Even if it's just one here, and you have turned it more than once. So first it was like this, but if it goes down and then comes back up again, then it'll have to go down again, right?
Yes,
Then
ma'am.
you will have 3 roots of p dash x, but you can't have 3 roots of p dash x because 13 are also already covered in these. 13 roots are already taken up by these 3. You can't have 3 roots. Now only 2 roots, place for 2 roots is left. That
Okay.
means other than these 13 roots, these 4, this one, other than this one, and this one, there are only 2 roots of p dash x left. But this, if you have this as your diagram, then this says that it should have 3 roots.
Ma'am, through that diagram, can we say that we can have one complex root also, because it is not, if it is turning one
So
more
you
time.
can't say that because you've already found 2 real roots. Each time you have this thing turning point,
How
that
did we
means it's a root of p dash x.
How did we found? Just want to know. 2 real roots.
Which one?
How did we found 2 real roots of this? Critical points, tangents.
Okay, do you agree that your x1, you have points x1 and x2, where the slope of this curve is 0, right?
Yeah. From the graph, I can found. There's no doubt in that.
Okay, and the x1 and x2 is not, these two are not -4, -12, and 4.
Yeah.
That means 2 are different from these.
Okay, got
And
it.
every turning point is a root of p dash x.
Got it. Yeah.
Converse is
Ma'am,
not true.
Just
for
one
Of
thing.
p
this
dash
graph,
x, just hold on a second, does not imply turning point. This is not true. But every turning point, if you have x1 as turning point, this implies your p dash x1 is 0. Is it fine?
Yeah, derivative will be 0. It means it has a turning point because slope is 0 at that point.
Ma'am, what is this line you have written? P dash x is equal to 0, not implies that x1.
Okay, if you have a point x1 such that your p dash x1 is 0, this does not mean that x1 is a turning point. But if x1 is a turning point, then definitely p dash x1 is 0. So if x1 is a turning point, it's a 0 of p dash x. But if x1 is a 0 of p dash x, then it might not be a turning point.
So that means it can be an asymptote.
Because
If it is not a turning point, we can say that.
no, it's not an asymptote. It could be a point of inflection. We can come to those later.
ma'am, for
Like this.
x cube, the p dash
Yeah.
x will be x square, right? I mean 3x
Yeah.
square. In that case, it is not
Yeah,
a
and then
turning point.
yeah, it's not a turning point. 0 is not a turning point in x cube.
Okay. And ma'am, for this
So
graph, if we are asked to find the number of turning points, then we can't find, right? If we are only given with the equation. For the
I have
this
found the number of turning points. No, we
no
have
ma'am,
3
no
turning
ma'am.
points.
For this graph which you have drawn, the right one, right side.
This one?
Yes, ma'am. If the equation is given, then can we find the turning points from this? The only equation is given. The graph is
If
not
the
given.
equation is given, then the entire case would be different. No, the graph would look like something. Okay.
It will
If you
look
are
like,
able to
but
plot this graph,
mhm.
if you have been given equation and you're able to plot this thing, then you can find the number of turning points.
But
1,
we
2, 3,
won't
4.
able to like draw this graph, right? Whatever we
It
studied
depends
till.
on, honestly, it depends on the equation.
Okay.
Ma'am,
If it is given in factors form and then some term like x square plus plus 1, where the d is less than 0, then we can find the turning points, right?
What?
suppose the equation is x minus 1 into x minus 2 into x square plus 1, let's say.
Okay.
So we are asked to find the number of turning points. Can we find?
This is -1. You'll have the roots on the other side. So you'll have 1 here, 2 here. And then because first check where your x goes to infinity, let's say. Then your px, let's call this px. Px goes to infinity, right? When x goes to
Yes.
infinity, px goes to infinity. And when your x goes to minus infinity, this thing goes to, this is plus, this is minus, this is also minus. So it again goes to this thing, infinity.
Ma'am,
And then
not there, here only, at 1, it will.
yeah. Bring it there. So at 1, because so this will cross this thing. And then at 2, it's also going to cross again. We'll have to turn here. Now, we have one turning point here, right? We have only this, it could be like this as well. As we've discussed, instead of this straight thing, you could have this thing here. Let's just check if that's possible. So if you'll take p dash x,
X minus 1
this
is
one's,
increasing, right? X minus 1 is increasing graph, right?
yeah, x minus 1 is increasing.
So then why you're like doing the downside when we are
But it doesn't depend on x minus 1. It depends on this thing. Your x is tending to infinity. As your x tends to infinity, your px tends to infinity. That's why it will go up. And if your x tends to
no,
minus
I'm
infinity, this will be
X tends
negative,
to
negative. That's how you draw things. First, you decide the end. And where is it going when your x tends to minus infinity? If your x goes to minus infinity, there are other factors as well. No, you can't
Ma'am, the
just
end
consider x
behavior.
minus 1.
Ma'am, what will happen to
Yeah,
this x square plus 1? This thing. Ma'am, from x minus 1, we get the root
there
1.
are
From
no roots from here.
okay, so it's
No,
a
we
kind
don't
of.
have any roots from here.
So what is the significance of this, ma'am? In the graph, ma'am, what is the significance of this then? X square plus 1. What will how
As
it will
such,
going to
in the
affect the
syllabus,
nature?
there is no significance.
Okay. Because x square plus 1 will also going to have some effect in the graph. So I was just asking what would be the effect of that.
It does have effect, but it's not explicitly in the syllabus.
Okay, ma'am.
Everything here has an effect. Okay, so, and then you can just find p dash x. So p dash x here, the total roots here, the degree is 4, right? So maximum p dash x can have 3 degree. That means it can have maximum 3 turning points. So either it looks like this, or it looks like this. Let me just draw it here. Or it looks like this. 1, 2, 3 turning points. These are the only 2 possibilities, right?
Yes,
These
ma'am.
are 2 possibilities. And then we can do something else to try to eliminate these. Try to find, there are other ways. For that, you'll have to go to double derivative to test if it's a turning point or not. And that comes under maxima
Okay.
minima, and you won't be asked things here on that, I guess.
So, ma'am, we can't conclude the number of turning points from here, right? I mean, for this question.
Just till this syllabus, you can't. But in your
Uh-huh.
later weeks, you can use that
Okay,
knowledge
okay.
to
But we
Okay,
can say
eliminate
that
using
there is
calculus, we can find, right? This double derivative test and all.
calculus.
Okay, okay.
we can say that there is at least one turning point from that.
Yeah, at least one turning point and maximum 3 turning points.
Ma'am, just one doubt I have from the previous thing that we have solved. You
Yeah.
said that yeah, these two roots there were 13 roots. Okay, then there were two roots which were you said either they are both complex or both real. But we can plot it on the
Yeah.
number line so that you can say that we can say that it's real. Suppose if
Both
it's
are real because you're not
yeah,
because
ma'am.
what you said, but because you have 2 points where the derivative is 0. P dash is 0. You have 2 points other than -12, -4, and 4,
Yes,
where
ma'am.
your P dash x is 0. That's why both roots are real.
But ma'am, if both are complex, then what could be the case?
Then you won't see the turning point here.
Then what we will see here, if not turning point?
You would not have, then you'll only have one turning point. One turning point you'll have only here. If both the roots were complex, then you won't see this turning point. these two turning points. You will only see this one, a turning point at -4.
So what would be at the place of the turning point of those two? It can be anything.
That's not going to happen.
Okay, okay.
Ma'am, is it correct to
Then
say
it's
that
not possible. No, you can, yeah.
one of the root which is -4 have that last turning point apart from these two turning points?
Yeah. This is the third turning point.
Yeah. So
These turning points, and then
we have
yeah.
13 roots. Okay. In 13 roots,
Yeah.
we have one of the root is turning point.
No. 13. Yeah. 13 roots. One of them is a turning point. 13
So
roots
it
counting
can also be
multiplicity.
okay. So it can
We
also
have
be 2 or
13
3
roots.
turning points, right?
No, it can't, because distinct roots you have only 3. That's what I've been repeating.
Okay.
Distinct roots are only 3.
Got it.
Counting multiplicity, you have 13 roots.
Got it.
Distinct roots, you have only 3, out of which 2 are not turning points, because you can clearly see they're not turning here on the graph.
Okay, ma'am. Thank you very much. Got it.
Okay. Let's come to the next one. Okay, so you've been given a function, and what's the domain of this? That's what the first option is asking. Yes.
Ma'am, so what is the conclusion for the above one?
It has 3 turning points. One turning point you're getting from here.
Yes,
Yeah.
ma'am. Understood.
This one or this one, I don't remember.
-4.
This one, -4. One turning point from here, and the other 2 turning points from these 2 roots.
Okay.
Okay, let's come to this one. What's the domain of this function?
-infinity to infinity.
Yeah, and natural numbers are clearly in this set, right? -infinity to infinity. That means this is defined for natural numbers. The first
Natural
option
number
should be correct.
starts from 0, right? Natural number.
Yeah, they start from 0.
So how it
But,
can be -infinity?
but ma'am, here it
This
is
is contained in.
written only for all, isn't it?
Is it only? If it's okay, then it's incorrect. Thanks. If it says f is defined for all x belonging to n, then option A is correct. If it says only, then it's incorrect. And then the second option says f is bijective function. So,
ma'am, but it is
forget
right now
about
because
real.
ma'am, one thing, f is defined only for ma'am, in the mod you cannot have a negative number, na?
Yeah, but it's not only defined for, it's also defined for 0.5. If you put x equals to 0.5, this
Real
function is
number.
defined for. It's defined for all real numbers. In particular, it's defined for 0.5, and 0.5 is not a natural number. Coming to the second one, it says that your f is bijective.
No.
So let's just, yeah, right. It's no. And if you have been given anything in mod and then a constant, then it's always a no. Because you're going to have, actually it can be, it's not always a no. Because you might not have roots for this one. So what happens is, if you've been given fx, yeah, or you've been given this thing, then it changes sign at the roots of fx, right?
Yeah.
It changes its direction, actually, not sign. It's going to change its direction if your fx has this root x1, x2, x3, then it's going to change the
So
directions.
it's actually not surjective. It's injective, right? Only injective.
It's not injective, because this thing is, you'll have to check, does this have real roots? If this has real roots, or you don't even have to check this, because your mod, this thing always looks like this. If this thing has a root, let's call it fx. If this thing has a root, that means it has positive and negatives, right?
Yeah.
It will have a positive value for some x and then a negative value. It is something like this, not exactly this thing. That's why this is not 1, 1.
Okay.
Or in particular, if you want to find an example, we can find an example too. Let's find the roots of this. That's enough. Do we have
Okay,
real
ma'am.
roots
Yes,
for
yes.
this?
3, 1.
Ma'am, one thing you said, whatever the function is in
3,
mod, it
1.
cannot be 1. Is it, ma'am? You said that, na?
No, it's not always. It depends on the function then. But in this case, you clearly have this thing, 3 and 1. These two are roots. If you consider this thing to be fx, then your f3 is 0 and your f1 is also 0.
For
And
same
0,
x,
by the
we
way,
are
is,
getting different
yeah,
effects.
for same x, you're getting, for
No,
different
no.
x, you're getting the same
Yeah.
fx.
So
That's why
it is
it's
not
not
1,
bijective.
ma'am. You are saying it is not 1.
Yeah, not 1.
Ma'am, but what are the ma'am? You said that if there is a function in a mod, it is not necessarily be a 1, but most of the time it is 1. It is not 1. Most of the time it is
Okay,
not
if you
1.
have fx, most of the time it's not, because let's say you have this thing, all right? Now, if you have roots of this function, more than 2 roots, if you just have x plus 1,
Mm.
then also this time you will only have 1 root, but it's still not 1. Or let's consider mod x. Mod x has just 1 root, right? So you can't use this logic here. For this function, you can't use this logic, but it's this, because it looks like this thing. That's why we know that it's not 1. At different x, you have same value for y.
So, ma'am, can we say that mod x is always not 1, always?
Mod x it actually depends on the domain. If you take mod x from 0 to infinity, then it's 1.
Yeah,
But if you take
exactly.
minus infinity to infinity, then it's not 1.
Okay, ma'am.
They can explicitly mention to trick the, tricky question like that.
Yeah, you can be asked on different domains. But if you're not given any domain, that means it's the natural domain of the question.
Okay.
And then coming to the third one, the range of f is 0 to infinity. So what's the range for this one?
17 to infinity, ma'am.
That would be
Yeah.
0 to infinity for this part only, mod part.
Yeah, the mod part is 0 to infinity, but you have 17 added here. So this value can never be less than 17. That's why the range for this question is 17 included to infinity. And this is not the range. This is incorrect. And looking at the range, because this is the range, the minimum value should be 17. So only option D is correct.
Ma'am, what about subjectivity? Can you just tell me in a second?
This is not surjective. No, surjectivity, there are real numbers. It depends on the function. It's not been given. If you've been given the function from R to R, then it's not surjective. But if you've been given the function from R to what
Range
is
is not equals codomain, right?
yeah.
Ma'am,
If you
ma'am,
take this, then it's onto.
ma'am, here the range would be 20 to infinity or 17 to infinity, because we have a
17
quadratic
to infinity.
function. But
And
ma'am,
your
for
quadratic
this,
function can take value 0.
but for this quadratic function, like it can have a minimum value at vertex, right?
And that
So,
minimum value is 0. That's why your minimum value for this is 17.
It cannot be
The
minus
minimum
1.
value of no,
Only
it can't
0.
be negative because it's mod. And you know that it's
but
sometimes what happens is
for
sometimes your
this,
quadratic equation is like this.
yes, yes. For
Then it
this
will change. But
quadratic,
this one, this has roots. This equation
oh,
does have root. That means it does touch the x-axis.
okay.
Is it fine?
Okay,
Ma'am,
okay.
it doesn't matter whether it has roots or not, but if you like apply common sense, then any value of x, even
No, you can't
infinite will
apply.
get.
If you change this thing here, x square, if you take x square plus 1 mod plus 17, then the range changes then. Because the range of this thing is not 0 to infinity.
Then it's
The range is 1, na? The range is 1 to infinity. For this one, it's 1 to infinity.
yeah. For this case, it's 1.
And but it's again going to be same because for this one it's 1 to infinity, and then if you'll add 17, so you'll have 18 to infinity, right?
Yeah.
Is this
Okay,
fine?
ma'am. Okay. Yes,
Ma'am,
ma'am.
just I have doubt in this one. How it is 1 to infinity and 18 to just one thing.
If you have x squared plus 1 in mod, so your y is equals to x, let's just consider this one. Y is equals to x squared plus 1 is like this. So it
Okay.
never takes the value 0. The minimum value this function takes is 1.
Okay.
The vertex is at 0, 1, right? The minimum value it takes is 1. This takes minimum, so this takes value from 1 to infinity, this entire thing. So adding 17 which should give you 18 to infinity.
Okay, so its
Right?
domain is 1 to infinity, you were saying. Close 1 to infinity.
No, its domain is not, its domain is real numbers.
Okay, and its range
Domain
is
is what you can put in place. Yeah.
So
Range is this.
x square will always be positive. It cannot be negative. So minimum value is 0 for x square. So x square plus 1 equals to 0 plus 1 equals to 1. And adding 17 will give 18. So 18 is minimum for you. It's like that. It's a
works too.
range.
And then what is 1 to infinity? This is range or what? 1 to infinity.
1 to infinity, I did for this thing. So the range of this is 1 to infinity.
Okay.
Range of x square plus 1 is 1 to infinity. Range of mod x square plus 1
Okay.
is also 1 to infinity. And then the range of this thing is 18 to infinity. Just add 17 to both of these. Adding it to infinity won't make any difference. Can we move on to the next question? Is this one clear?
Yes, ma'am. I guess one
Ma'am, I have
option
a
is
question.
left.
Ma'am, can you check the answer of the above? Because I think the first option is also right. Because when you will solve it, na, x square minus 4x plus 3 more than 0, more than and equal to 0, the value of x will always come as natural number. Can you check the answer of it?
You're not asked if it's natural number or not. You're
Ma'am, because
asked the values
it,
for which it's defined.
yes, ma'am, but when you do x square minus 4x plus 3 more than 0, more than or equal to 0, the
This option is not correct. You're asked the domain. You have to check if the domain is only natural numbers or not. What do you think is the domain of this thing?
Can you go to the next one?
Ma'am, in the question, if the mod was not there, then it would have been the range would have been from minus negative infinity to positive infinity.
No, it actually depends then. If this mod was not there, then you'll have a quadratic equation, right? So it depends. Then you'll have this something like this: ax square plus bx plus c. So either your parabola will be this, or it will be downwards like this. So in this case, your range is from here to plus infinity. In this case, your range is from here to minus infinity, or minus infinity to this.
Okay,
It's
got it.
based
Thank you.
upon the value of A, no, ma'am.
Value of what?
A less than 0 or greater than 0.
Yeah, it depends. Yeah, upward, downward depends on a.
Yeah, so it's positive, so it's upwards.
Okay. Can we move on to the next one?
Yes, ma'am.
Please.
Yes.
Okay, so this is the next one, which is the question clear? Is it clearly visible?
Yes, ma'am, it is.
Okay. So this is a very simple question. This is 1. This is minus 1. So multiplicity of minus 1 and 1 must be same. So although it looks like they're same here, because this one also crosses, this one also crosses. But we just know that the multiplicity of both of these is odd. We're not sure if they're going to be same. So this option should be incorrect. Coming to the next one, your px is increasing in this interval. This is 3, I guess. So in 3 to infinity, if this is 3, then it's not increasing. If this is 3, then it is increasing. It's not very clear from what is given. If this is 3, then this option should be correct. If this is 3, then no. If this is 3, I guess this is 3. This is 1, right? 1, 2, 3. This is 3. So your px is increasing from 3 to infinity. This should be correct. And total number of local minima is, this is a local minima, 1. This is again a local minima, 2, 3. And then that's it. This is also correct. And then you have the total number of turning points. So one turning point here, 1 here, 2, 3, 4, 5, and we have 6. That means this is incorrect. Is this fine?
Ma'am, this px is increasing in the interval 3 to infinity. So, like, if we change the order, px is increasing in the interval infinity to 3, then like, how should we consider this?
Infinity to 3 is not interval. This is not an interval. You always write it as this. Smaller first,
Okay, okay.
and then the bigger one.
Okay, okay.
Now, how
From
first
left
round?
to right on x-axis,
Yeah,
right?
Yeah, it's
minus
left to
infinity to
right.
3, you can say.
Yeah, minus infinity to 3 is the correct way of writing. This will be incorrect.
Okay, okay, okay.
Ma'am, can multiplicity be same?
Multiplicity, it can be same, but if you say must, that means they have to be same. That's why this option is incorrect. It can be same, it can be different.
Ma'am, but in the graph, from the graph, can we say that
Okay,
it
ma'am.
is same?
No, you
Can be
can't
3
say
or
from
it
the
can be.
graph.
It can be
Can't
3,
we
it can be
say
5,
that
any odd number.
can't you say that
Sorry, what?
multiplicity is 1 here?
Ma'am, I plotted
No,
this
how do you
graph in
conclude that?
Desmos. Yeah, I plotted this graph in Desmos. I'm just sharing the screen for it. One second.
Because it cuts the x-axis, but
You don't have to make this in Desmos or anything because you have not been given the polynomial. And as long as you have not been given the polynomial, you can't judge from just the graph. Only judge the things that you're sure about.
Based on where the minima comes, no, the local minima, you can see that it comes just below the 4. Based on that, can you just see the screenshot alone?
Okay, just give me a second. I can see the screenshot. What about it?
But in this, actually, both -1 and 1 multiplicity is 1 only.
That's what I'm saying. You cannot just put it in Desmos. How do you judge a graph if you have been given a graph? And only pick the things that you are very sure about. Don't assume that this graph looks like, you can just change it.
Yeah. It could be like x
Only
minus.
things that you're sure about. Like this is a turning point. We're sure that this is a turning point. Why? We're not using Desmos because we know that this is turning here. That's why we know this is a turning point.
okay. Instead of must be, if
We
it
know
is
that,
given can be, then it could be a correct
yeah,
option,
if
right?
it has, if
Ma'am,
it was
can you
can, then it would be correct.
Ma'am, in the TS session, the sir has told when the multiplicity is more, the graph is more stretched in a way, a little bit.
What?
Ma'am, can you just explain the local minima and maxima? Just a short.
Okay, local minima is, let's say you have this point, right? Local minima means you should have an interval on x-axis around this point where this function is first increasing and then it's no, for maxima it should be this. So for maxima there should be an interval on x-axis such that first your function is increasing in that interval, then it's decreasing. Then it's a local maxima. What happens is if you've been given the graph to be like this, right? Then you might think that this should only be, this is the global maxima. You will study this in later weeks. This is global maxima because global maxima means the maximum value of the function. Local maxima means if there is an interval in which the function's value is maximum. So in this interval, this function attains the maximum value here, right? That's why this is a local maxima. Even if you were given this, then this is a global minima. And this one is a local minima because there is an interval around this point where this function is first decreasing, then it increases. Is it fine?
Okay, ma'am. Can you show the graph? I can judge it.
Ma'am, but from the graph, we can have two local minima and one global minima. So it should be two local minima, but we have
global minima is also local minima. We cannot know whether it's
Yeah,
global or
global minima is also a local minima.
Okay, okay.
I
Global
just
minima
said
also come in the local minima only. Okay.
definition of local minima is you should get an interval on x-axis in which your function is first decreasing and then it's increasing. Now your interval could be this small, it could be even smaller, it could be larger, but there has to be an interval. That's all.
So, ma'am, global minima also come in the category of local minima.
Yeah, global minima is a local minima.
When you know that the graph is attending its lowest point, you know that the global minima lowest point.
In a
That's what you-
particular interval,
Huh.
if you know that this graph attains minimum in a given interval, in any given interval, then it's a local minima. But if there is no interval in which the graph attains its minimum value, then it's not a local minima.
Yeah, the second part is even more lower. That's why it's global minima.
Yeah, this is the lowest actually.
Yeah, and the first part is global maximum because it's a maximum of the graph where graph has reached.
Yeah,
that's why.
Ma'am, even if domain is given, then also global minima or global maxima will be like local minima or maxima.
Yeah, even if your domain is given, then also the global maxima is a global maxima is a local maxima.
Okay, thank you, ma'am.
Okay, and we have some other questions
Can you
for
show the
revision.
Ma'am, what was the last sentence you said to the student? The local minima, global minima.
A global minima or a global maxima is also a local minima or a local maxima.
Okay, ma'am.
So global minima is, we've discussed this a lot of times, right? Just now. Okay, let's just do some questions that I feel are a little important. So first question that we're doing is, let's just say you have been given a line and you've been given the x and y intercepts of this. So you have been given please mute yourself. So this is, let's say you have been given a line and x and y intercepts are given for L1. And then let's say you've been given, so this is x intercept, this is y intercept, this is x intercept. These two are given to you. You'll join these 2 points, so you'll find the equation of L1, right? And then let's say you've been given the ratio in which a point, any point on this line divides this line. Let's say you've been given P could be 1, 2. If it lies on this line, I'm taking a very rough thing. And let's say this divides this line, P divides this line in M is to N. Just 1 second. Yeah. So we were discussing this thing, and you have been given that this P point divides the line in ratio M is to N. So let's say in 1 is to 3. It divides it in 1 is to 3 ratio. And you can be asked to find the equation of this line, the line that joins 0, 0 and P. So can you do this question?
Yeah, it's origin and it's
Ma'am, if
perpendicular.
P is given, then by
Is
2,
x minus x
2
1 by y.
point.
It will be a 2.4.
Ma'am, here the P is
Intersection.
already given, right? That is 1, 2.
Yeah, the point is already, or even,
If P is not given, then we have to
yeah,
find the P, then
let's say your P is not given and the ratio is given. It could be asked either way. I'm just telling how the questions could be framed.
okay.
So it could be that your P is not given and you have been given that this P divides the line in 1 is to 3. And you've been asked to find the equation of OP, where O is the origin.
So
First
we need
and
to
you've
know
been given x, y intercepts.
y and x.
Yes.
Yeah, okay.
First we have to
Y
find
x
P.
intercepts are given. First
Okay,
you
we will
find the
find
equation
P.
of this line.
Use the section formula.
Ma'am, what is the y and x
Or you
intercept?
don't actually need the equation of this line.
Yes, ma'am.
You won't need, in this question, you don't need the equation of the line. You have been given 2 points, x, y intercept. And then for there's something called section formula. If you have a line, let's call this point as A, this as B, and it divides it in the ratio 1:3, P point. Then the coordinates of P should be, where x will be, let's take the coordinates of this one as x1, y1, this one as x2, y2. Then the x coordinate is going to be x1, 3 times x1, 3 times x1, and then 1 time x2, divided by 4. Sum of these two.
Ma'am, is
And
x1 and x2 are given in the question?
yeah, x1, the x-intercepts and y-intercepts are given. This is given to you. Or it could be given in some other form. The equation of the line could be given, or then you will have to find the x and y-intercept. I just want to make sure that in every possible manner, you can find the things by the
Ma'am, if
given information.
equation given, then can we found the ratio?
If the equation of this line is given, then also that's what I'm saying. If instead of these points, x and y intercepts, if you've been given the equation of line, then you'll first find the x and y intercept, and then you will use the section formula to find the point P.
How can I find x and y intercept to the equation of line?
Okay,
Put
for
x
x,
equal to
let's say
0
you've
or y
been
is equal to
given,
0.
yeah, one time put x equals to 0 to find y intercept.
Okay, got it. Yeah.
Should I write it down?
No, ma'am, got it.
Okay. That's all. This is one type of question that you can be asked. It can be
Can you
changed too.
just explain how did you use the section formula 3 divided by 4? You took 4 x1, y1, x2, y2. That's 4 or
Divided by 1 plus
This
3.
is m is to n. Then the formula becomes mx2 plus nx1 by m plus n for x coordinate of the intersection point, right? And for y coordinate, it's
got it.
this. We've used the same formula here. Okay. Then should I solve this question or
No.
can you guys do it? Okay.
What are the other
And
things?
then let's just say you have been given a question where you have been given general equation of the line. And just 1 second.
Quadratic. That's not a line.
Hello? Yep. So this thing, and let's say you have been given other pieces of information. So you could be given y-intercept, or you could be given vertex, or we have an or here, or something else, or some point on this line. And then you can be given, let's just say, let's just take an example.
You're supposed to find A, B, and C.
Yeah, first you will find A, B, and C, and then you will find if something else is asked. You might not just be asked to find A, B, C. You might be asked to find something else. So let's just say you've been given that the vertex is this. This is your vertex. And your y-intercept is, let's say, 0, 1 only, because this is very obvious. If your vertex is this and y-intercept, let's take something else here. If your vertex is 1, 1, and this is 0, 1. If these two things are given to you, then you use these two things to find the equation, right? Are these two pieces of information are actually enough to find for you to find the equation of the line, and then to find A, B, C, because you have been given 2 points on line. What?
Y can't be same, no, for vertex and y-intercept. That will be just as same. Okay, just for example.
Yeah, because it will be the same piece of information. Or what you can do here is, if you have been given this thing, then how do you use this piece of
But
information?
it can't
Vertex.
be practically, because if the
They'll
vertex
put
is
in the
then
equation.
That's an example.
No, it's practically possible. The vertex and y-intercept can be same. X
Yes,
minus
ma'am.
1 whole square, a times, right? And then you need to find a. To find a, you have been given another piece of information, which is this. The reason why I was not taking it to be 0, comma 1 is, if you take it to be 0, comma 1 here, if this is your vertex, and you know that then it's either this or this, then the y-intercept is also this, right? So you'll only have one piece of information. Is that fine?
Ma'am, how did you
That's
got
why
this
I
equation?
changed it.
Hello.
But I am
So
saying
then
it
the
is not
quadratic
graphically
equation
possible.
is,
Ma'am, I am saying it is not graphically possible because vertex is 1, 1. Suppose vertex is 1, 1, 1. Suppose you take
okay,
vertex as 1, 1, and when you take y-intercept, it will not be 0, 1 actually. Because if it is going forward, it will be more than 1. That is my point.
yeah, that's
Yeah,
also right.
so that is not
But we're
feasible.
just taking examples. They are not feasible, but we're
Just an
just taking an
example.
example.
Just an example.
Just an example for you to understand. And
We
if your
can
vertex
increase
is AB,
the y-intercept to be 0, 2,
yeah,
not 0, 2 or 0, 3, so that it is solvable in a way.
let's just get done with the class because it's already half hour past the actual time. That's why I'm not taking the whole example.
Ma'am, how did you got
So
this equation ay minus 1 equals to this?
that's what I'm explaining. If this is your vertex of quadratic equation, then the quadratic equation looks like this. A times y minus b, where your a is some constant, b is this, and x minus a whole square. So here your a is 1, right? And b is also 1. So we've just put ba equals to 1 in both these equations, in this equation. And then you have to find a. To find a, you've been given another piece of information, which is this. That 0, 2 is a point on this curve. So put x equals to 0, you will get minus 1 whole square. Put y equals to 2, you'll get 2 minus 1, it's 1. That will give you a. That means your a is 1. That means your equation is y minus 1, x minus 1 whole square. Is this fine? And then you can be asked further questions on this.
From where
For
did you get
example, you
a,
could be asked
ma'am, from where did you get a y minus 1, that thing?
this thing. You put y-intercept here. Y-intercept is a point on the parabola, right? Just
Okay.
put y equals to 2 and x equals to 0 in this equation.
Intercept. Okay.
And let's say further you have been given
That equation, how you got on the above? You
one,
are this above, a little bit above.
this one.
This a, yeah.
This we got from here. If AB is your vertex, let me just write it down clearly. AB, if is vertex, I don't want to take AB because AB has already been taken. So let's take T1, T2. So if T1, T2 is vertex, then the equation becomes this. Y minus T2 and x minus T1 whole square. And you have an A here, where A is some constant which you have to find. So if vertex is given, then this is the equation of your parabola, where A is unknown. So you'll have to find it.
But how does the equation become like this?
Should I do the whole proof of that here? It's
No,
not
ma'am,
needed.
just brief it,
If you'll open it,
just brief it a little bit.
It's not necessary, but it's not there in the lecture, ma'am, in this vertex form.
Brief it, like how
even
did
if
it?
you don't use it, you can use other methods. This is just easier. That's why I've written it.
Okay. Okay, ma'am.
Easier for you to find.
I've thought of intercept form, that formula.
Intercept form.
X by a plus y by b equals to 1.
That is for line, but that is for line, not for curves. This quadratic equation.
That is for
Okay,
lines.
your equation is, we'll have to do the whole derivation of that here then.
I don't think that's
We don't have,
necessary.
No, ma'am, no need to. I mean,
No
it
need.
is not
Ma'am,
necessary.
is that vertex formula or how you derivative
vertex
mean?
formula.
It's a
It's a vertex
formula. Okay.
formula.
Ma'am, you
Yeah,
just
because
tell
vertex
the
is
application how you did it. You don't solve it, just tell us how did you get it by putting what? Just
There's a whole I'll have to derive it here. I can't just tell you.
No,
Or you can
you
just,
can
what you
skip
can
that
do
one.
here is, you can, but that is not a sufficient, that's explanation that I'll give here won't be sufficient. You'll have to derive it.
can you verbally tell from what to put in
No,
what?
well, if I,
It's okay, ma'am. You can browse the Google and chat with
you
it.
just,
You
if you
just
don't
type
want to use this
from
formula, we can
vertex
use
how to
something
draw
else.
the quadratic equation. You'll be able to get it.
If
Is
you
there any
have
other
been given
questions
AB
that,
as what?
ma'am? That's okay, ma'am. Is there any other
Ma'am,
questions
you
that you
can
want
just tell
to?
us a little bit.
Man, she's trying
What
to give us
happens is,
some
okay, I'll tell
highly
you.
important questions, man.
Y, let's say you have y is equals to x. Y is equals to x is this line where this passes through. So the main point here is 0, 0. So your 0, 0, when you do y minus a and x minus b, instead of this equation, if you've been given this equation, then your origin gets shifted to b comma a, right? So this origin gets shifted to b comma a. If this point is b comma a, then your line looks like this thing. So this line, which has been translated, looks like this. Now, if you'll have, if 0, 0 is your vertex, then it looks like this, right? The quadratic equation is this. So if you'll translate it by AB, you'll have x minus a. That means your 0, 0 got shifted to AB.
Okay, ma'am, got
So
it.
you'll have x
Yeah.
minus a whole square and y minus b here.
We have constant also there on the
Yeah,
left.
we have a constant too.
And from where the constant came, it is just the constant is just
The constant you have to keep. What happens is if you have this line, because you know that it passes through this, but your constant will change this slope, right? It'll change the slope. In this case, if you'll translate this entire thing exactly to a b comma a, then it looks like this, parallel to this one. But the slope can change. So if you'll take a here, what happens is it changes the slope. That's what it does here. Same thing.
Basically, stretch factor. Ma'am, is there any other question that you want to tell us?
Yeah, there's one more question. Or you can be given, we've already done, I guess, a question on when you record the coefficients incorrect. So in this question, when you've already found the equation, let's say you have all, with this information, you can find the equation, right? And then you can be asked that this equation has been wrongly recorded by someone else, say, and they recorded B wrong, the coefficient B wrong. They've noted this coefficient wrong.
Okay.
So then you can be asked, there could be questions from there.
Got it, ma'am.
So you could be asked to find the roots of incorrect equation. The correct equation was this ax squared plus bx plus c, where your a, b, c you find using this thing, this information, right? We already did this thing here till this part. And then you could be said that this coefficient is written wrong, or this thing is written wrong. Someone noted this down incorrectly. Someone noted this down incorrectly. And then you could be asked to find the roots of that thing. Is that fine?
Yeah, got it. Any other question?
Would be given what the other person noted. And then
Okay. Means that will be given, right? I mean, the question that what was
yeah,
the
it would be given
actual thing, actual A or B?
not the actual thing. You will be given what the other person noted incorrectly. Because the actual thing you have to find, right?
Okay.
A, B, C you have to find. Incorrect you will be given. Or
Okay.
it could be the other way around. Okay, and then you know how to find the equation of a line using a point and given slope, right? 1 point and slope
Yeah.
given.
yes, ma'am. That is
Yeah.
Yes, ma'am.
That's
And
all,
then
ma'am.
if you've been given that you have two curves C1 and C2, and it says that this It could also be given that the line passes through the point of intersection of these two. And one more piece of information about this line will be given, like
Slope.
the slope of this line is something, or you can be given another point. And then you can be told that the other point on this line is the point of intersection of these two lines.
Got it, man.
You will
Yeah,
have
we
to
should
find the point of
equate
intersection of these two.
and find the point
Yeah.
of intersection, then slope point.
Okay, ma'am.
Equate y's from both of these, and then you will find the point of intersection. One point you find, one point will be given, or you will be given slope, or you will be given something else about this line.
Okay, ma'am. Got it.
Got it. Any other? That's all.
I think that's it.
Ma'am, just one thing.
Like
When
this one, let's just say, let's do one example on this. Let's say you have been given this thing, where you have been given your px equals this. Then you've been told that this passes through, let's say, the vertex of this thing. And then you will be asked to find a, or something else, coefficient of x square here, coefficient of x square here,
Coefficient
or
of x
coefficient
square
of
is
x cube.
a only here, ma'am.
So it's, you don't know what the coefficient of x square is. Coefficient of
Sorry,
x
sorry.
cube is
X
going to
cube
be a.
is
Cube
a.
is
Yeah,
a.
yeah, yeah.
Yeah.
Yes, ma'am. Yes.
Let's say x square, you will have to solve this thing. You can be asked coefficients, you can be asked a, you can be asked something else about this thing using this, that it passes through the point. So everything is given here, only a you have to find the complete curve, right? And that
Yes.
is given to be passing through, it could be given that it passes through the point, through the vertex of this, or the y-intercept of this, or the x-intercept of this.
Okay, ma'am.
So
Okay,
first
ma'am.
you find the vertex or y-intercept, whatever is given. First you find that point on this line. And then what is the vertex of this, by the way?
6,0. Oh, sorry, 6,6.
ma'am, it would be
6
comma
comma.
minus 6.
Yes, ma'am. 6 comma minus.
6 comma minus 6. That's why I told you this thing, so that you can just directly tell from here. Otherwise, you'll have to do that
ma'am, this
entire
is
thing.
it has a minimum value. It is an upward graph, na? Yeah.
Yeah. Is it fine?
Yes, ma'am.
How do you first you find that point which has been given on this one, and then you substitute this point here because you know that this point satisfies this equation, right? So what you do is you
Ma'am,
put
what is the
px
question
equals
that
to minus 6.
these two graphs intersect and we have to find that point? Is this the question?
No, the question is, this is an equation given to you, and they say that this equation or this curve passes through, let's say, the y-intercept of this. Let's change this thing. What's the y-intercept of this curve?
From the 0. So 6, what is it? Yeah. 36
It's
minus
this,
6,
right?
no?
It's 30. Y-intercept is 30.
Okay, we have
36 minus
minus here.
6.
All right,
36
not
minus
30.
6.
It's 30. Then, so you know that this, because this curve passes through the y-intercept of this curve, right? Or y-intercept of this curve lies on this curve. So y-intercept is this, and this lies here. So you put x equals to 0 here. You'll get a minus 1 minus 2 minus 5, and y equals to 30. So y is this, right? Put 30 here, and then you can find the value of a, which is minus 3. Is it fine?
Yes,
Yes,
ma'am.
ma'am.
Okay, that's all.
Ma'am, I have one doubt. When you derive that, just before that, just before this, yeah, just before this thing, yeah, just before this, yeah, yeah. When you told that we have to, yeah, just above it, more about it. When you were telling us A into, yeah, this one. Yeah, ma'am. So this one, A into y minus t2 is equal to x minus t1 ka whole square. So you said t1 and t2 are the vertices of the quadratic equation here. So what is the application of this? Like what you were telling, the main thing?
So there's application means practical life examples that this uses. We're not doing that here.
No. The question. What is the question that can come from this? What?
The question could be, you could be asked to find A, you could be asked to find A, B. This is the question, right? You could be asked to find the sum of these coefficients. A, B, C. For that, you need to find, if you need to find the sum of A, B, C, you need to find A, B, C first, right?
T1 and T2 are the vertices.
And T1, T2, because the vertex is given to you, 1, 1. So you can use that info here.
Okay, and the quadratic
All this
equation is,
entire thing.
yeah. So the quadratic equation is
Just
ax
find,
square plus bx plus c1 is equal to 0, and the vertex form and its vertex form is a into y minus 1 is equal to x minus 1 ka whole square. Like this, the vertex form is this. So this is the same quadratic equation of the form ax square plus bx plus c is equal to 0.
yeah.
When
If
we
you
put,
open this thing, then you can
okay,
compare the coefficients.
okay. Ma'am, but just one thing, I'm not able to know that how it is derived. Can you tell us?
I just told you, no, you shift the origins.
Yeah, that
So if
I
you have
understood.
this thing,
Yeah, that I
you
understood,
want
but
me to formally derive the entire thing mathematically.
yeah,
It's already 1 hour past.
yeah. But
It's
if
11 now.
yeah, ma'am, but if you can verbally or just tell it in a way, one
This is
sentence,
the
I'll say that.
verbal part. And for mathematically doing it, you'll have to derive it.
I think you can see in
See,
Google.
what you can't understand, no?
Yeah.
See, basically
Why
she's
you are
You
looking
can
stuck
at
just
there.
our
you can just use
point,
chat
and
GPT.
Yeah,
A is
why you
just
are
the
stuck
stretch
there.
factor. That's
See, the
all.
class is over. You can go. Let me ask ma'am.
I don't
Yeah, I'm
think ma'am
clearing
has
your doubts,
But
man.
it's
That's what I'm saying.
Ma'am,
already
these questions
past
can be
1
asked
hour
in
past the
discourse
time.
also.
Yeah,
This
just put
question can
them
be asked in
here.
disposal. A is the
Ma'am is
stretch factor.
telling
That's all.
me, if ma'am is telling
You're
me,
shifting
let
the
me
point, and A is like stretching
Okay,
the
we'll
graph.
end
That's
the
all.
session here. Let's not stretch the argument.
ma'am, can you tell me the first line
You
of it?
can ask this in discourse.
Yeah,
And it's a
I'll
very
ask it
simple
to the
derivation. You
discourse and
can
I'll
check it
email
on.
it to it also. You know, in the proper way, I'll email it. I'll let you know it how it happened. Tell everybody how it
Okay, so I guess we can just end the session here then.
Yeah, thank you.
Thank you, ma'am.
Yes, ma'am. Thank you, ma'am.
Thank you, ma'am.
Thank you.
सुपोजित आता जाता कुछ है नहीं मुझे भी पूछने दिया करो
Ma'am, do we have more revision session? I think ma'am has left. Okay.
Yeah, I think she's.
Shugit, I am asking the teacher. If you don't want to, you can leave.
Sai, that's what I'm
अरे
saying.
तुम तो छोड़ यार
I
मैम
cannot
मुझे
follow.
बता रही है ना
Hey, poda day, ni pesa puri lada.
लड़ना
Poda,
है यहाँ पर आ जाओ
Okay,
लड़ना है यहाँ
okay,
पर आ जाओ
Okay, this is getting recorded. You
अरे
follow.
मैम
listen,
मुझे
bro.
बता रही है ना तू तेरा काम कर और जा मीटिंग से
Hey, anybody
दो
can
घंटे
answer,
से
man.
2 घंटे
Anybody can answer.
क्लास बता रहे तो आपको कुछ भी टाइम में वो सेंस नहीं है क्या?
मैं तो बताता हूँ क्या
Anybody
सेंस है
can answer.
भाई
मैं
सुनो
बताता हूँ क्या सेंस है
भाई
मैं
सुनो
बताता हूँ
You
क्या
have a
सेंस है
doubt.
अगर
Anybody
पुराने
can
बता